Hi, and we are back for day 3 of the Kotlin online event. Welcome back, everyone. You might remember me. I'm still Sebastian. I'm still a developer advocate for Kotlin here at JetBrains. And I'd like to thank all of you for tuning in from all around the world. The motto of today will probably interest a lot of our viewers at home because it's Android and multi-platform. And we have 4 wonderful talks lined up. One about Android, one about multi-platform mobile. You're going to see me talk about Kotlin JS, and we're also going to have a deep dive into Kotlin multi-platform. I'm really looking forward to take all of you through this day together with my colleague Alina.
Hi, Sebastian. I'm really excited to be here for the 3rd day of Kotlin Online event, and the first 2 days were really great. I enjoyed them a lot. Did you have a chance to watch them, Sebastian?
Well, I have to admit, I didn't really have time to watch the first day, but that was mainly because I was hosting. But I did actually watch part of the recording, and of course, I looked in I peeked in during the 2nd day. I was very happy to see that Sveta's talk also covered my favorite data structure, the array deck, once more. So very happy about that.
True. Cool. Yeah, I've been watching both days and chatting with our audience, and yeah, it felt so good. Great vibes, great jokes from you, Heidi, Igor, and Katya. And yeah, I will make sure today event is fun for our audience as well. And it's a special day today because it's the first time when we're gonna have an external speaker, Florina Muntenescu from Google. And we will start with her talk just in a few minutes. But before, let me remind about our activities.
Also, let me introduce my colleague here, who's because this is Android, this little plushie is going to be my co-pilot for the first part of the stream for sure.
Oh, this is so cute. Cool. Oh, where did it come from?
Oh, this actually came from a Google event we had at our university back in the day. So he's been guarding my couch ever since, and now he finally gets to see the whole wild world.
Yeah, it's really cool. So getting back to our activities, every day our event just wraps up with the Q&A session. We really strongly encourage you to post your questions to our speakers. You can simply do it on YouTube chat, on YouTube or on the website, wherever you are watching us. Or you can post your questions on Twitter with the hashtag Kotlin1 4ask. Don't put dot there. Dots are not recognized by Twitter, so Kotlin14ask. This is a hashtag. That's how we will find your questions in the Twitter feed. And another great part about Q&A sessions and about your questions is that the author of the best question can win a prize. It's an awesome mug branded with Kotlin 1.4 online event logo. And by the way, I guess we have winners from yesterday. Sebastian, do we have them?
Absolutely, we do. So let me introduce the 3 winners with the best questions from yesterday. They are going to get a mug that even I don't have the chance to get, which is very unfortunate because I love mugs. Today's stream is sponsored by my unicorn mug, which I hope you can see. Starting with question number 1, which came from Malvin. How do JetBrains decide what features go into the standard library versus extended libraries? Then the second one comes from Flyrox or Flyrox. Do you see flows replacing libraries like RxJava, or do they have their own uses apart from maintaining legacy code? And the third one comes from Jamie. Are we ever going to get suspendable properties? Suspendable lazy val would be really helpful. Now, we had those answered on the stream yesterday. If you are interested in the answers, go back. But more importantly, if you are one of the 3 people I mentioned, Malvin, Flyrox, or Jamie, please get in touch with us. Alina, how do they do that?
Oh, yeah, you can use our email, kotlin14org@jetbrains.com, right? And I'm going to post this email to our chat. on YouTube so you don't miss it. Please don't forget to reach out to us and to let us know where we can ship your mug to you. So yeah.
And of course, the interaction doesn't stop here. As with the previous days, we have a quiz quest for all the upcoming talks here as well. Initially, we kind of thought that maybe Alina could share some more detailed information about the exact rules, but we decided we'll just keep it simple. We're going to raffle off these prizes on October 26th. Please make sure that you register with the same email address for each quiz so we can tally up your points properly. And you can win t-shirts, bottles, backpacks, all of these kind of different things. And for the detailed rules, because Alina didn't want to go on stream and explain them, you can just look on the actual site there under the stream as well.
Yes, that's correct. That's true. Well, and I think it's time to introduce our speaker to you. And speaking first is Florina Muntenescu, as I already said. She's an Android developer advocate at Google, and her talk is State of Kotlin in Android. And now, let's enjoy the talk.
Hi, Android has officially supported Kotlin since 2017, and there are good reasons why we fell in love with Kotlin. First of all, the language takes care of a lot of boilerplate, allowing the developer to spend more time focusing on the business at hand. Next, Kotlin's strong type system helps prevent runtime issues like no-pointer exceptions and string format issues. In fact, we did the numbers on the top 1K apps, and we found that amongst the top 1,000 apps on Google Play, those that use Kotlin have 20% fewer crashes per user than those that don't. Android developers have been writing their apps using the Java programming language for many years, and there's a wealth of existing libraries written in Java. It would be hard to get started with Kotlin without the seamless interop with the Java programming language, allowing for gradual adoption of Kotlin into existing projects. And if you're still not convinced why Kotlin is a great fit on Android, later in this talk, I will show you how coroutines and structured concurrency solve one of the most difficult problems developers face when writing Android apps, running asynchronous operations in a unique way. A recent survey shows that developers who adopt Kotlin are on average 50% more likely to be very satisfied with their programming language. The same survey shows that 60% of Android Pro developers are using Kotlin in their codebase. And more than 70% of top 1,000 apps in Google Play Store now contain Kotlin code. The credit for creating and maintaining Kotlin, of course, goes to JetBrains and its wonderful teams of engineers. Since officially supporting Kotlin 3 years ago, Google has stepped up to help this awesome project. Together with JetBrains, we formed a foundation for Kotlin to ensure that the language ages well. For example, through a careful process of vetting breaking changes. But our contributions extend beyond policies and reviews. Google has a team of engineers contributing to the Kotlin compiler as their full-time job, currently focused on helping get the new IR backend and frontend compilers ready. We're also working on building Kotlin-related tooling, such as Kotlin symbol processing, about which you'll learn a little bit more later in this talk. We've also been improving the way we teach Kotlin on Android. We've created or updated documentation, ensuring that the samples are in Kotlin as well, created collabs to help you learn Kotlin, and articles and videos targeting all levels of developer experience and familiarity with Kotlin. Finally, we've been working closely with JetBrains to bring Kotlin to universities by creating a university curriculum and training professors to teach Kotlin in faculties in India. Here's an overview of some of the ways we've expanded Kotlin support in Android in the last year. On the library side, we've added new Kotlin-first libraries, such as Paging 3 and Jetpack Compose. We've also added new Kotlin extensions for Play Core and Google Maps. These make using the existing APIs more Kotlin idiomatic. As Android developers, you spend a lot of time interacting with the Android SDK. And that's why on Android 11, we've added more nullness annotations, making your calls to those APIs safer. Developers' productivity comes from great tooling. As such, we've added built-in Android Kotlin Live templates, which allow you to use shorthand to add common Android constructs to your Kotlin app. At the same time, new Kotlin-specific lint checks help you make Kotlin code more language idiomatic. And actually, this is specifically useful if you're transitioning from the Java programming language to Kotlin. Looking at the compiler toolchain, R8, our shrinker tool, contains new Kotlin-specific optimizations. For example, eliminating Kotlin intrinsic checks when it can prove the whole application doesn't need them, and Kotlin metadata rewriting that allows the compiler to recognize, for example, extension functions and suspend functions, which don't exist natively in the JVM. Materials to help you learn Kotlin are also expanding. For example, Kotlin Vocabulary is a YouTube series that explains a different Kotlin keyword in each video. Make sure to check it out. Looking at documentation, we've updated our Kotlin page on developers.android.com. And there's one update that I want to highlight here. The new case studies page, where you can read about the benefits that different apps saw when adopting Kotlin. Finally, Kotlin Everywhere, the program we ran together with JetBrains and other Kotlin developers around the world. And it's reached over 30,000 developers, showing the incredible enthusiasm for the language from communities globally. And speaking of last year's Google I/O, that's when we first unveiled a new project that will define the future of building UIs on Android. And it's built entirely on Kotlin. I'm talking, of course, about Jetpack Compose, our new unbundled declarative UI toolkit, made for the demands of rich, beautiful, modern apps. It reached an important milestone just a few weeks ago, and is now available for everyone to try in alpha. If we look closely at the Compose project structure, we see that Jetpack Compose using a custom Kotlin compiler plugin to transform the declarative UI functions you write into the app's UI elements. The plugin is built on compiler extensions that we built in close collaboration with JetBrains. What I like a lot about Compose is just how nicely it leverages a lot of the Kotlin idioms. Functions are the basic building blocks, relying heavily on higher-order functions, trailing lambdas, default arguments, and more. But Kotlin at Google is not about just Android and the externally facing libraries and tools that we released. Within Kotlin, we're also doubling down on Kotlin. Over 60 of our apps are now using Kotlin. And here you see a few of Google's most popular apps that have all started using Kotlin in their code base. Our large internal code base counts over 2 million lines of Kotlin code. And we've recently started using Kotlin for server-side code too. As part of us building Kotlin support for our internal code base, we've added Kotlin support to some of our core libraries, such as gRPC and protobuf. The gRPC work has recently been open source, and protobuf will follow soon. We're also using our large internal code base to help vet the new compiler work that is available in Kotlin 1.4. And speaking of Kotlin 1.4, it brings many improvements. On the compiler side, this includes language additions, type inference improvements, and generating type annotations in bytecode for Java 8+ targets. On the library side, 1.4 brings a common reflection API, program configuration for Kotlin reflection, and new contracts. The release also brings a slew of performance improvements all across the board. Kotlin 1.4 is available for Android instantly, whenever you decide to switch to it, without waiting for any OS updates. These new features help with productivity for sure. However, the biggest thing that will help your productivity is tooling performance. And we've heard you. Both JetBrains and Google are working hard in this area. The new front-end compiler, which I mentioned earlier, will deliver large improvements. But as writing a new compiler is a large undertaking, and we want to make sure that the compiler is not only fast, but also correct, it will be a while until this is available for stable release. So we need to make sure we add additional performance gains in the meantime. We've been working on supporting the Kotlin Gradle plugin to make annotation processors more incremental, as well as helping annotation processor authors make their annotation processors ready for incremental runs. To help track down IDE performance issues, the Google and JetBrains team have been organizing combined performance hackathons. These have led to numerous improvements in Kotlin 1.360 and above. On the Gradle side, we're working with Gradle Inc. to make drastic changes to its model for incremental compilation under a project named Instant Execution. Combined with additional caching for faster up-to-date checks, we're seeing up to 30% improvements in controlled experiments. This work is under heavy development, so expect more news in the coming months. If you're a library author, then performance matters even more for you, and there are several tools that can help you. First is the explicit API mode in Kotlin 1.4. With this mode enabled, the compiler helps you be intentional about the public XPI you're exposing when writing a library. In this mode, you have to explicitly declare visibility modifiers and type specifications. To enable it, update your Gradle file to add the explicit API file. Then, depending on your configuration, these explicit APIs can produce errors for strict mode or warnings. Next is a new project from Google called Kotlin Symbol Processing. Our data shows that many Kotlin builds are significantly slowed down by annotation processors. The Kotlin toolchain needs to perform lots of magic to make these run seamlessly between Java and Kotlin, leading to performance concerns. So we have been working on Kotlin Symbol Processing, or KSP for short, as an alternative to this. Instead of using KAPT, developers can now build lightweight plugins that run as part of the Kotlin compilation process. KSP allows for incremental resolution of symbols, and from porting some existing annotation processing, we've seen 30 to 40% faster compilations. KSP comes with a rich set of APIs and provides access to all Kotlin symbols, including ones that are not available in the Java programming language, such as properties, function types, and more. KSP is multi-platform ready, so you can write your symbol processor once and use it on all target platforms your project uses. While KSP is still in developer preview and not quite ready for production usage, we want to invite existing annotation processor authors to give it a spin and provide us with feedback with the short link visible on the slide, or via the KSP Slack channel on kotlinlang.org. All right, starting with AGP 410 Beta 03, adds support for Kotlin metadata rewriting. Kotlin metadata is used by the compiler when linking against libraries written in Kotlin, so that the compiler can recognize, for example, extension functions and suspend functions which don't exist natively in the JVM. Kotlin metadata is also needed for Kotlin reflection calls at runtime. So previously, R8 was unaware of the Kotlin metadata, so when shrinking a library, it would remove or destroy the metadata, making it no longer usable. With new versions, it will correctly process all Kotlin metadata information, making it useful for library authors wanting to process their libraries with R8, as well as for compiling code that uses Kotlin Reflect. Okay, I'm sure you're all familiar with the async task class, right? Just in case you haven't moved to other solutions for async programming, in Android 11, we mark this class as deprecated. Okay, so what should you use instead? Well, developers have turned to various custom solutions involving threads, executors, or higher-level libraries such as RxJava or Guava. And with Kotlin, there's one more contender, and that is coroutines. Coroutines are the Kotlin way for asynchronous programming, with full support in the language and libraries since version 1.3, released over 1.5 years ago. In one of our recent surveys, we saw that over 50% of professional developers who use coroutines are seeing increased productivity. So here you see a small example using coroutines to perform an asynchronous call to retrieve survey data, followed by an asynchronous call to store the data in a local database, followed by a UI update. Coroutines code is executed in a scope. In Android, we have libraries to tie the lifetime of these calls into the Android lifecycle. Dispatchers allow you to schedule execution of network and database access on an I/O background thread. Async network calls can be made through libraries like Retrofit that support coroutines out of the box. And here we're using Room's coroutine support to store the data on the device without blocking the UI thread. Finally, we pass the value on the view model to be displayed in the UI. With all these asynchronous steps, the IDE clues you in on any asynchronous behavior with an icon on the left of the code. We've recently announced that coroutines are the recommended solution for async code on Android. And if you haven't adopted Kotlin yet and are struggling with asynchronous programming, this is another great reason to take another look at Kotlin. You might wonder why so many developers choose to pick coroutines as their async solution and why we stand by their choice with our official recommendation. Coroutines are a particularly good fit for mobile apps running on Android. Structured concurrency helps developers scope the work to the application lifecycle and prevent memory leaks. Next to this, callback-free code is easier to read and less error-prone, while built-in support for cancellation and natural exception handling helps ensure the error case is handled gracefully. Many of our APIs already support using coroutines. To enter the world of coroutines, we've created special-made coroutine scopes that allow you to run async code inside view models. And within this scope, you can make use of the coroutine support in various Jetpack libraries. Let's look at a few examples. So, for example, in the Android Room library, you can easily access databases without blocking the main thread through coroutines. All data access statements, insert, update, delete, and query, provide a suspend version and ensure that the database is accessed on a background thread for you. And query allows you to return flow as well, not just the suspend functions. Like this, you can observe the changes in your database as they happen. Meanwhile, longer running tasks are often modeled through jobs inside Work Manager. With Coroutine Worker, you can easily model job cancellation. If the database and HTTP client provide suspending version of their APIs, we have suspending calls all the way down. Everything looks sequential and it's easy to read. The functionality for both Room and Work Manager is provided via extension functions and KTX artifacts, so extensions to existing libraries. But in some of our new libraries, we started with coroutines from the ground up. And a great example is our new Paging 3 libraries. So, for example, to define a source for the list of users that you need to display on the screen, you would implement a paging source and override the load method. As load is a suspend function, you can easily call other suspend functions, like a backend call. Then paging allows you to work with flow of paging data, giving you more flexibility and finer-grained control of the data you end up displaying. Another example of a library built on coroutines and flow is Data Store, which is a new and improved data storage solution aimed at replacing shared preferences. So Data Store provides two different implementations. Proto Data Store that lets you store typed objects backed by protocol buffers, and Preferences Data Store that stores key value pairs. Data is stored asynchronously using coroutines, and it can be retrieved using flow. So, for example, here I'm getting a setting from the Data Store, and every time this setting is changed, my counter flow will emit the new value. Jetpack Compose also provides integration with coroutines. So, for example, you can launch a coroutine in the scope of a composable. Like this, you get to call suspend functions in your composable. So, coroutines are the recommended solution for async code on Android. But what does this recommendation mean for Java users and people who have adopted other high-level asynchronous programming libraries? So, the great thing about coroutine libraries is that it makes it entirely possible to write interop support for both libraries. So, for example, paging will ship with RxJava and Lessable Future compatible APIs. Conversely, for libraries that have not yet adopted the coroutines API, you can use many third-party adapters, such as the one that converts a task-based API from Google Play services to coroutine suspend calls. And you can even write your own. We recognize that many of you will want to begin learning about coroutines, and we made sure we've got you covered. Over the previous months, we've been updating our learning materials, including our coroutines collabs, multiple coroutine articles covering a wide range of topics from basics to deep dives into coroutine internals. And finally, you can check out our conference talks from Android Dev Summit, Kotlin Conf, as well as specially recorded coroutine intro videos. So, to wrap things up, I hope it's clear to see that Android loves Kotlin. The language helps developers be more productive and makes them happier with their toolset. We continue to expand support for Kotlin within Android, and Google is expanding its own use of Kotlin, both in our Android application and on the server side. Google is working closely with JetBrains to make the language and tools even better. Kotlin 1.4 brings many enhancements, and we would love to hear your feedback on the Kotlin symbol processing. Coroutines are now our recommended way of doing asynchronous programming on Android for Kotlin developers, as it provides a structured, easy-to-read, and less error-prone way to do the many asynchronous tasks Android developers need to code all the time. For those new to Kotlin, we hope our continuously expanding documentation, code labs, and videos helps you get started easily. And with that, thanks for watching.
Thanks a lot, Florina, and welcome to our virtual studio. By the way, do you remember the first time you came in contact with Kotlin? What were your thoughts?
I don't think I can remember like the first line of code, but I do remember the first pull requests that I wrote. And more specifically, I remember writing them, let's say, very, very Java-y. And I remember the comments that I was getting to the PR, and my reaction of like, oh, you could do that? Oh, that's so easy. And yeah, I think that's the feeling, and that feeling actually surprisingly still continues, because every time I write some code and then gets reviewed, and like, oh, but did you know that you could also use this or this extension or this other method or operator? Then yeah, I get to learn a lot. And I think that's one of the reasons why I like code reviews, because I get to learn a lot. Yeah.
Well, no, absolutely. I feel like exchanging information and exchanging knowledge and little tricks, that's probably where it's at. And it's probably one of the most efficient ways to learn, I'd argue.
Yeah, yeah.
Good to know. And Sebastian, what about you? When you first tried Kotlin, do you remember?
Wow, this was a while back. I was still studying back then, you know. But yeah, since I think I've told this story at least once before, I started on iOS, and then at some point I wanted to get back to the JVM ecosystem, but I was kind of spoiled by the way that kind of Swift had introduced me to all these new and fancy language concepts. But I really loved the JVM ecosystem, so yeah, I ended up kind of searching for an alternative language, and yeah, Kotlin turned the corner, and I immediately fell in love. But honestly, though, we're not here to talk about us. We're here to talk with Florina.
Skip my answer.
Yeah, that sounds like a great idea, because we actually have a lot of questions we do want to go through.
Yeah.
One of them comes from Dmitry, who asks, hashtag Kotlin 1.4 ask, first of all, on Twitter. Should I really migrate my Java-based Android apps to Kotlin, or can I keep working with Java?
We recommend moving to Kotlin. I think last year at Google I/O we announced that Android is going Kotlin first. So this means that actually a lot of the libraries that we are building are not just built in Kotlin from the beginning, but they might only be usable in Kotlin. So for example, right now, some of the latest Jetpack libraries we created, like paging or data store or Jetpack Compose, are written from scratch in Kotlin with Kotlin in mind. I think that's one of the things actually that I liked both about paging and data store, that for them, coroutines are, I'd say, like the backbone of the libraries. They're just so built in, and it's so easy and natural to use them. And then if you think about Jetpack Compose, right now you could only use it when you're using when you have a Kotlin code base. So yeah, I'd say migrate to Kotlin.
Okay, I would agree with this, and I'm not even an Android developer, so.
Yeah, cool. The next question is from KVRHK. Shall we avoid using Kotlin synthetic or not?
Yeah, I think I got this question also on Twitter, and then several folks said yes +1 and asked the same question. So we created the view bindings, and view bindings actually solve the same problem as synthetic, so allowing you to access the views without all the casting. So I would say use view binding if you need to do that. Extra, from what I know, the synthetics library is not, first of all, it's not owned by Google. I think it's owned by JetBrains. And from the last I heard, the project tends to be quite abandoned and probably going to be deprecated soon. So yeah, I would say consider moving to view binding.
Okay, all right. Our next question comes from Harshit, who asks if anyone, and by anyone I assume they mean you, Florina, has the best course for Kotlin for Android, because they need it.
Yeah. So actually, we created several courses for Android. If you go to developer.android.com/Kotlin, you'll actually find several ways to get started with Kotlin. So we have content targeted to learning Android and Kotlin from scratch with a course focused on Android basics in Kotlin, but we also have different code labs or different ways of learning Kotlin, either for existing Android Java developers or just for folks that want to get even more in-depth with Kotlin. So I would say if I put this link somewhere, maybe we can publish it afterwards. But yes, check out our documentation because we have courses for Kotlin on Android.
Okay, well,
yeah, I've just dropped it on our chat, so no worries. Yeah,
wonderful.
Everyone can find it there.
With the delay, this might feel a little bit like we are coming from the future, but
no,
in due time.
I took proper time. That's fine. I tried and control that. That's fine.
Very good. Very professional broadcasting setup right here. All right, you want to take us to the next question?
Yeah, we have the next question. This is from Lookback, who actually won a prize after the first day. A prize for the best question, I mean. So, how using Kotlin helps developers in Google?
I think that I covered part of this in my talk, but actually in Google, I think now we have, I don't even remember the name. I think the number, I think something like 50 or 60 apps that are using Kotlin. So I know stuff like Google Home, Google Drive, Maps are using Kotlin in their code base. And oh yeah, I remember one from the talk I gave just before. I think right now there are more than 2 million lines of Kotlin codes written at Google. So it's not just something that we say, oh, Android is going Kotlin first, but it's also something that we are using internally. And we also use it on server side as well, not just on Android.
Oh, that's actually very exciting.
By the way, yeah. So if I recall correctly, there are a few stories, developer stories on the same portal, right? On developerandroid.com.
Yeah.
So there are stories from Google as well. So one might want to check this out.
Yeah.
Wow.
Yeah, it's actually really interesting. Also, because of the scale of things sometimes when we talk about the Kotlin apps. So I know I'm going to give spoilers from some documentation that I know we're going to release soon. But I was reading that Google Home, because since it started adopting Kotlin, and it saw a 30% reduction in crashes. And like, for me, that's huge, especially for an app that's, it's installed on quite a lot of devices. So yeah, 30% reduction in crashes is impressive.
Yeah. So just since you mentioned it, by the way, and you quickly brought up Kotlin on server side, I of course want to advertise our 4th day of this online event as well, where we're going to have a couple of lovely talks from JetBrainers and also from folks from Spring who are going to talk about everything Kotlin server side. So be sure not to miss that as well, because I think you'll learn. Yeah, I think you'll be able to learn something interesting and something new there as well. I have one more question here, which comes from Amar. I've done the basics of Java, and now I want to be an Android developer. Is it the right time for me to switch to Kotlin?
Yes, I would say that the right time to switch to Kotlin is
yesterday.
I would say first now, but I think yesterday, yeah.
Very good.
Let's say now, just so we don't put that much pressure on developers. But I would say yes, definitely switch to Kotlin.
Okay, that's great.
Yeah, and the next question is from Malvin. Do we need to migrate existing apps written with RxJava to coroutines? What benefits do we get of moving from one lib to the other?
I think need is a strong word, but I would recommend it. So to give you an example, there's one thing I actually like with Kotlin coroutines compared to RxJava. So if you need to do one-shot operations, usually with RxJava, you would use the single, for example, or completable kind of observables. But with Kotlin, you would use suspend functions. And the code that you write with Kotlin coroutines just feels so more natural than the one that you write for these kind of one-shot operations with RxJava that, I don't know, it just feels much easier to write. So I think that's where the advantage comes from. But also, if you're thinking about migrating from one to another, there's I think RxJava and Kotlin interop, so it's easy to go from one to the other and the other way around. Yeah, so I would say consider migrating, at least consider playing around with Kotlin coroutines in parts of your code, and just to see if you are able to find the advantages. And I think you will once you are starting to play around with these single shot operations.
Okay, great. Then we have a great question here, which I'm really happy about because I can answer it. The question is, will the slide deck be available? And I'm probably going to go out on a limb here and say, just like the other slide decks for the other talks, this one is going to be available on the website as well. So if you just navigate your way through kotlinlang.org, you'll find that quite easily. Let's maybe round it out with one last question. I think we have time for that. Actually, let's do 2 quick-fire questions. Am I correct to assume that Android Automotive is also Kotlin first, asks Spring Hawk?
I don't know anything about Android Automotive, to be honest. So, yeah, I don't know. That's my answer.
Okay, great. Well, I can speak to the fact that BMW was hosting a Kotlin Everywhere event last year. And since they are automotive, I'm going to assume that they have at least some kind of stake in this as well. And then the last small question would be, what framework does Google use on server side with Kotlin?
On server side, I have no idea. I'm afraid I never wrote a single line of code on server side.
Then, of course, we expect you to join as a viewer on the stream tomorrow and learn all about it and maybe write your first Hello World, maybe with Ktor. I'm sure Hadi would like that a lot.
Yes.
Yeah, join us.
Okay, well then, thank you so much for joining us
Florina.
here.
Yeah, thank you everyone for all the questions and for watching the talk.
We'll see you again later for the big Q&A. Make sure not to miss it. So if your question hasn't been answered, there's a good chance we'll bring it up later. We'll say goodbye for now.
Thank you for having me.
See you.
Okay.
Wow. Let's continue.
Yeah, those were a lot of questions. You folks are active in the chat, and we love it. That's great. Now, our next talk comes from someone who you've already seen on stream yesterday, one of our hosts. It's our very own Kate Petrova, who's a developer advocate for Kotlin Multiplatform Mobile. And very fittingly, her talk is called It's Time for Kotlin Multiplatform Mobile. So I'm really looking forward to that. We have gotten the question again in the chat, how do I get a mug or how do I get a t-shirt?
Oh yeah,
the answer to that?
I think I can answer this one.
Very good.
So to get a mug, you can just go ahead and post more questions on our chat or on Twitter with the hashtag Kotlin1forask. And to win a t-shirt, you should try your luck with our quiz quests. And each quiz quest open after the talk. So now the next one should be opened already. And you can check out the quizzes from yesterday and the day before. And yeah, that's how you can win a t-shirt. And even more, there are backpacks and bottles. So more prizes you can win.
Wonderful.
That's it.
Pay close attention and let's enjoy the talk together.
Hi, my name is Kate and I'm a developer advocate for Kotlin. In this talk, we are not going to spend much time discussing why you should try to make your applications cross-platform. Don't repeat yourself is kind of a mantra, the main principle on which a lot of architecture patterns are based, and it's because of many heated discussions in pull request comments. Reusing code is good, and we've all known that for a long time. This is Alex and Anne. They're in love with mobile development, but neither of them likes doing the same job twice. So today we'll help Anne and Alex to take a journey into a wonderful world of cross-platform mobile development, and we'll see how KMM will help them along the way. We'll look at all the different stages of mobile application development and learn how to use KMM features to optimize them. How do we usually proceed after we decide to stop duplicating the same code for different platforms? Of course, we start by comparing the existing solutions out there and looking for one that will best fit our needs, because the choice we make could greatly affect the architecture of our existing applications and any we create in the future. To understand the variety of options available, let's first take a look at the architecture of a standard mobile app. Basically, it consists of several layers: the UI layer, presentation layer, business layer, and data access layer. If we imagine a scale where the bottom point is core and the top point is UI, we can see that the most popular cross-platform approaches are UI-centric. What does it mean? Well, it doesn't mean that you can't write business logic code. Of course you can. It means that the whole ecosystem is focused mainly on developing UI components. But when you decide to write something more complicated than just sending HTTP requests, you will be almost alone in this wild, vast cross-platform world because of a lack of libraries and practices. However, these technologies allow you to create similar interfaces for your apps very quickly. So this approach is absolutely justified when you have simple apps, thin clients, or if you just want to make an MVP to test your product assumptions. But when your product starts to grow, the UI quality and responsiveness requirements get stricter, and the business logic becomes too complicated for your UI-centric approach. This is where the business logic-based approaches came in. We already have well-known players here, such as strategies to have shared C++ or JavaScript code. As always, they come with different advantages and disadvantages. One of the most harmful disadvantages is the need to add one more additional language to the existing code base, together with its own tooling, ecosystem, and rules. Well, this doesn't seem like the easiest way to avoid duplicating some parts of your code. Let's go back to Anne and Alex. Anne already has an existing project with complex logic, while Alex has just started to plan his new mobile app. But he has big ambitions for it, and he doesn't want to find himself rewriting his entire application one day. So they both want to share only a specific part of their code, and they don't have time to learn a new language and deep dive into an unfamiliar ecosystem? Well, folks, good news for you. You can achieve this with Kotlin Multiplatform Mobile today. With Kotlin Multiplatform Mobile, Ant and Alex can immediately start sharing business logic between iOS and Android applications in any project without any limitations on the UI development process and in their favorite language. Sounds good, so let's have a look. Some of you, of course, may have heard about Kotlin Multiplatform, or KMP. Some of you may have heard about Kotlin Native, and some of you may have just started to learn Kotlin. Hey, welcome! To make sure we're all on the same page, let's make things clear and figure out what Kotlin Multiplatform Mobile is. Kotlin Multiplatform Mobile, or KMM, is an SDK for cross-platform mobile development. It uses the multi-platform capabilities of Kotlin and includes various tools and features designed to make the end-to-end experience of building mobile cross-platform applications efficient and enjoyable. KMM allows you to use a single codebase for the business logic of iOS and Android apps. You only need to write platform-specific code where it's necessary, for example, to implement a native UI or when working with platform-specific APIs. Whenever you want to use iOS or Android features, you can use the expect actual pattern to write platform-specific code with shared logic in the KMM module. KMM is seamlessly integrated with your mobile project. Shared code written in Kotlin is compiled to JVM bytecode with Kotlin JVM and to native binaries with Kotlin Native. So you can use your KMM business logic modules just like any other regular mobile library. And KMM doesn't impose any restrictions on how you develop your app's UI. So KMM equals Kotlin Multiplatform plus the mobile-specific stuff around it. What is the mobile-specific stuff? The best example is the new KMM plugin for Android Studio, which allows you to write, test, run, and debug shared code in the same IDE. But let's start from the beginning. Let's go through the development process of a typical mobile application and see how we can use KMM to make it cross-platform. But before I start speaking about app architecture, let's first figure out what kind of projects are suitable for integrating KMM. Alex is lucky. He has a new project. It's always easier to speak about app architecture when we are going to create a new application. You have a drawing board in front of you, and you can use whatever architecture you want and almost any kind of technologies, as long as your company doesn't mind. But Anne already has a project, and she doesn't want to wait for a new one to start reusing code. So what about existing projects? Do we need to go back to the drawing board to start sharing code between platforms? Good news? No, you don't. KMM is seamlessly integrated with any mobile project. Shared code written in Kotlin is compiled to JVM bytecode for Android and to native binaries for iOS. So you can use your KMM business logic modules just like any other regular mobile library. So technical details of KMM integration are the same in both new and existing projects. Just add a new dependency. The only difference is in the process. For a new project, you can start developing new features in the shared code, then write native UI and connect it with your shared business logic. There are different strategies for integrating with an existing project. You can take Kotlin code that has already been written for Android and refactor it by using only pure Kotlin libraries and make it compatible with iOS. Or you can take a new feature from a backlog, and then the process will be the same as for a new project. So let's help Alex with his case. Alex loves space, so he wants to create a mobile application that will get information about SpaceX launches, store it in a local database, and display it in a list. Well, yes, it's quite a simple application, but as always, it's a beginning of big story. And as the integration of KMM is almost the same for both new and existing projects, and anyone else who wants to use KMM with an existing code base can easily use the same approaches. Okay, so we need to develop a typical mobile application that retrieves data from the API, displays it in a list, and caches it in a local database. On the first architecture design stage, we need to decide what part will be shared, and what part will remain native. Let's go back to our architecture diagram. KMM is designed to allow you to share the business and core layers of your app. When we're creating a new mobile app, we don't want to spend a lot of time thinking about organizing the data layer. It's such a common task, so there should definitely be some building blocks to do it quickly. KMM provides exactly these building blocks. The ability to use platform-specific APIs along with expect actual pattern allows you to create them without reinventing the wheel. The Ktor HTTP client is a good example of such a block. Like all multi-platform libraries, it provides several artifacts, one with common logic for all platforms and drivers for different platforms, which allows you to use the platform-native capabilities to perform HTTP requests. The other building block we need is Kotlin X serialization, which we will use to deserialize JSON responses into objects of entity classes. And the last one is SQLDelete. This will generate Kotlin code from SQL queries to create a type-safe database API, which we will use to communicate with databases on iOS and Android devices. As a Ktor library, besides the core artifact, SQLDelete also provides platform-specific database drivers, one for Android and one for iOS. For the domain layer, let's add a couple of entities. In Alex's case, there should be entities for rockets and for launches. And let's also add wrappers for Ktor and SQLDelete libraries that will allow us to get the data as business entities and hide some core details. The entry point to the KMM shared model will be the SpaceX SDK class, a facade over our networking and caching service. Now we have a mobile SDK, which could be used in our application. It also can be easily distributed as a separate mobile library to allow other developers to create clients for our web service. This is a very simple KMM module architecture. It's quite enough for Alex purposes, but of course you can write more layers of abstractions to make your code even cleaner. Now we are done with architecture, so let's figure out how we should configure our project. There are three main parts of any Kotlin multi-platform project: targets, source sets, and compilation. A target is a part of a build that is responsible for building, testing, and packaging the application for a specific platform. Source sets are collections of Kotlin code files along with their resources, dependencies, and language settings. A source set can be used in Kotlin compilations for one or more target platforms. Each target can have one or more compilations, for example, for production and test purposes. In our cross-platform mobile project, we need to declare two targets, Android and iOS. The common dependencies that are used in all targets need to be declared in the common source set. In our case, they are Ktor, Kotlin X serialization, Ktor serialization feature, and the SQLDelete runtime. And since Kotlin 1.4, stdlib is added by default to any Kotlin Gradle project, and there is no need to declare it explicitly. Thanks to the new multi-platform libraries publishing format, since Kotlin 1.4, you should specify a dependency on the multi-platform library only once in the shared source set, instead of specifying dependencies on different library variants in all source sets where it is used. So we can declare a dependency on Kotlin X libraries or on the Ktor feature, as in this example, just once in the common source set. However, we still need to explicitly specify dependencies on Ktor engines and SQLDelete drivers, because there are many of them, and it's impossible to determine automatically which of them to use. This tiny iOS declaration hides some tricky KMM model configuration details for iOS target. The thing is that the iOS simulator and iOS device currently have different processor architectures. So to be able to run and test our app on both of them, we need to compile our shared code for two targets, not for one. Starting from 1.4, Kotlin multi-platform supports a hierarchical project structure that allows you to have intermediate source sets and use platform-specific APIs in them. You don't really need to think about it while you're working on the shared code of your mobile apps. Everything just works out of the box. But if you want to know more details about how all this works under the hood and what engineering challenges we overcame to make everything work as it's supposed to, watch Dima Savvinov's talk. It's a very interesting journey, I promise. Before we start writing code, let's discuss our app architecture a little bit more. Well, I know for mobile developers, discussing different architecture is considered to be a hobby. Jokes aside, we've discussed core and business layers, but what about presentation? Do we need to share it or not? We definitely can do this, and there are already many community libraries that allow you to do this and have plenty examples of their usage. But you need to think carefully. Do your apps look similar enough to have one presenter of your model or controller for both of them? Could this change? I'll let you make the decision for yourself about your apps, and we will go with only shared business logic. After all, it's never too late to do some refactoring and move more layers to the shared model if you are sure that it's worth it. Our application architecture is now designed, and we know how to configure our project. Let's finally write some code and discover some KMM features. Of course, KMM is seamlessly integrated with Android. Use Kotlin for every part of your project and work in the same IDE both for shared code and for platform code. But we are writing shared code for both platforms, and KMM also provides tight integration with the iOS development process. Thanks to the Kotlin native bidirectional interoperability with Objective-C Swift, you can call Kotlin code from Objective-C Swift and use iOS libraries from Kotlin. You can integrate KMM models in a natural way for iOS developers using the CocoaPods dependency manager. And you don't even need to switch IDEs while working on the shared code. With a new KMM Android Studio plugin, you can write, run, test, and debug shared code all in Android Studio. Let's take a closer look at these features. Alex created a single function in the SDK class, which returns the list of launches from the database. So we can easily use our KMM model API in Swift. Kotlin's list is mapped to Swift array, so calling this function looks very natural. But before getting the cached data, we need to load it somehow. So we need to make an HTTP request. GetAllLaunches is a suspending function, so our public getLaunches function needs to be marked as suspending too. There is no such concept in Objective-C Swift, but you don't need to worry about it. Suspending functions are available in it as functions with callbacks. When you have such functions in the generated framework's header, you can call them from your Swift or Objective-C code and even override them. Our HTTP client can throw an exception during the GetAllLaunches call. There is fundamental difference in error handling between Kotlin and Swift. All Kotlin exceptions are unchecked, while Swift has only checked errors. Thus, to make Swift code aware of expected exceptions, Kotlin functions should be marked with a throws annotation specifying a list of potential exceptions classes as parameters of throws annotation. Now we can handle all exceptions in our completion handler in Swift code. This was just a small example of Swift Objective-C interop possibilities. It supports all fundamental concepts and doesn't require additional setup, allowing you to integrate with KMM models in iOS applications without a headache. Kotlin Native also provides integration with CocoaPods dependency manager. You can use KMM models as a CocoaPods dependency, or you can add dependencies on pod libraries stored locally or in the CocoaPods repository. You can manage pod dependencies directly in Android Studio, enjoying full coding support. On the subject of Android Studio, with a new plugin, you can create a new KMM project or model with just a few clicks, and you get integration with your iOS device and simulator directly in Android Studio. With a new Kotlin Multiplatform mobile project wizard, you can create a ready-to-run mobile application project with a shared codebase in just a few clicks. The generated project will contain examples of how to connect to platform-specific APIs and basic test coverage. You can use this wizard to explore basic features of KMM or as a scaffolding tool for your new KMM production application. I'm sure this wizard will help Alex start developing KMM applications much faster. You no longer need to switch IDEs and have Xcode running to check that your code works correctly on both mobile platforms. You can run and debug the iOS application on the simulator or device with the predefined run configuration. You can run and debug common and iOS-specific tests on the iOS simulator by simply clicking the Gutter icon on a test class or test method. For both the application and tests, you can set breakpoints and debug your code on iOS. After writing our code, we want to test and deploy it, obviously. You'll be glad to hear that there are no big differences in this process, as your shared code is connected like any other regular dependency. Only difference, if you want to optimize your manual QA work now, is that because the business logic code is reused, you don't need to test some features on both platforms, and you only need to do it once. Congratulations! We've designed the architecture of our app, created a project with a KMM plugins wizard, written some code in Kotlin, and integrated it into both our iOS and Android apps. You can find the complete project with a step-by-step tutorial at our hands-on portal and use this as a guide to creation your KMM application. Alex and Anne looks really happy because now they definitely know how to stop duplicating code for mobile platforms. And we've learned that it's definitely time for Kotlin Multiplatform Mobile. Why is today a good day to start? KMM is now in alpha. This means that the Kotlin team is fully committed to improving this technology and helping it evolve. It's also a signal that the product will develop quickly from here now. Going alpha means that everything is ready for you to start using KMM to share business logic code between mobile platforms. You can create a new project or easily integrate a KMM module into the existing one. In both scenarios, the work can be done with minimal cost, and you can always go back to fully native development. And the community is growing really fast, and you can influence the development of the whole ecosystem by participating in it. So what's the best way to start? The new KMM developer portal is your trusted resource when you are working with KMM. You will find content for all levels of expertise, from tutorials to get you started to more advanced development topics. It contains useful information about common tasks, like organizing networking and data storage layers, and even organizing the development process around KMM. Looking for new ideas about benefits of using KMM in your application? Learn from a first-hand experience of a variety of teams, for example, VMware, Quizlet, and Yandex, who are already using KMM in their products in the case study section. And try the new KMM plugin. With the new wizards and iOS integration, you can create a new KMM project in a few clicks and start exploring all the KMM features. Thank you, and have a nice Kotlin!
All right, it's good to be back here in our cozy little virtual studio. Joining me are Kate and Dima Savvinov, who's the team lead in Kotlin Multiplatform Mobile, in case you didn't know. And if you didn't, shame on you. Now, Kate, you already hosted our event yesterday. I think together with your talk, people have already gotten a pretty good idea of what you like. So I think we can probably skip directly to some kind of community questions. But actually, I've learned one thing from you, and this is this whole like social media influencer thing, right? Apparently, we need interaction in the stream, right? So I'm gonna ask you specifically, if Kotlin was a type of fruit, what kind of fruit would it be?
Oh my God! Learning from the best, yeah, Sebastian. Yeah. Good thing. Yeah. So I would choose, I think, maybe pineapple, because it goes pretty well with everything. You can eat it with a fruit salad, or with a meat, or with a fish, or you can make a pizza with pineapple. So
Don't do that.
Yeah.
Okay, well, if you are watching at home and disagree, please put your answer in the chat and let us know why. I think we can move on to some more serious questions.
Okay.
Yeah, let's do that. And the first question we have from Mariam. There is a statement, not really a question, but we need more resources about Kotlin Mobile Multiplatform, official guides, and more advanced samples. And the question from myself is, Kate, what would you recommend for us and our audience?
Yeah. Of course, we definitely realize that the lack of comprehensive documentation examples is one of the biggest points when we're speaking about integrating KMM, and that's why we've put a lot of effort in developing our new documentation portal, which I mentioned in the docs. So And by the way, thanks for all folks who also helped us with this TouchLab team, IceRock team, and Code Coders. We did together, and I think it's brilliant. It's a really great case. So all folks who are interested in KMM, I suggest you to go to this portal to search through these docs, and I think you would find some widgets there, you know, this sometimes annoying widgets about, do you like this article? Please don't miss them, and put the button and rate the article, because we really use this information to prioritize our documentation backlog. And you can always drop us an email. You also will find our email there at the bottom of the page, and we regularly check it. And I think the main problem is to prioritize, because of course we have this huge backlog. Yeah, so we are waiting for your feedback.
And when in doubt,
and if Igor,
when in doubt, of
if
course, you can
Igor
always
were
send,
here,
exactly, send to feedback@kotlinlang.org. That one is always open, and Yegor reads it every day.
Yeah.
So yeah.
And switch on your stats on IntelliJ IDEA. I don't
Exactly.
remember this consequence of the steps, this exact order, but I believe you can find it in Igor's talk. Yeah, so, and by the way, I wanted to mention that the link to Kotlin Multiplatform mobile portal is right on the event website. It's in the resources section, so you can go there and find everything useful what Kate mentioned on Kotlin Multiplatform mobile developers portal.
Okay. I'm going to bring up another question, and maybe that they need to censor me, but I'm going to say the F word here. How can we use Kotlin with Flutter or with React Native?
That's a really popular one. Well, I will start from the end. We don't have any plans about creating some specific stuff around this combination, like wizards or some samples or docs. But as I said in the talk, the result of KMM is just a platform library. It's a native code for your iOS. It's a jar file for your Android application, so you can just use it as a regular dependency. And if you're speaking about Flutter, you can combine, you can call for your API by method channel and Flutter method channel for iOS. So you can Google this combination, like Flutter plus KMM, and you definitely will find some articles from some crazy guys, crazy in good meaning, who already did this. Yeah.
Okay, that's very cool. Looks like Kotlin really goes everywhere.
Like pineapple, yeah.
Except for pizza.
Yeah, don't touch pizza. The next question is from Malvin. Does JetBrains have any plan to extend the testing framework for Kotlin MPP to include things like mocking library, spec framework, and test coverage?
I think I will pass it to Dima.
Yeah, so currently we don't have any short or midterm plans to provide such a support, like write those frameworks inside JetBrains, but we actually very eager to see whether those frameworks can maybe move to multi-platform, and we are very welcome to see them there. And we already see that some of frameworks considering migrating to multi-platform and providing a multi-platform support. So I know it's kind of a dodgy answer, but it's up to community, and we are happy to help community with this.
Okay. One more question comes from Saifur, who asks, if I have a payment provider library with two separate packages for Android and iOS, can I make a Kotlin multi-platform mobile variant?
Mm-hmm. Dima, as an expert of Kotlin multi-platform mobile libraries.
Yes, definitely. And actually, that's a pretty awesome case for KMM, because in such cases, you really care about the logic being the same on iOS and Android. Because if you make a mistake and the logic diverges on Android and iOS and its logic in payments, it can be very, very bad. So in KMM, you can share this logic, and because it's mostly a business logic of payments, it fits KMM pretty nicely. So yes, Of course you can, and there's a documentation, and yeah, just you can check the next talk. It's a little bit technical details, but still it might get you a very interesting context on how you do this.
Yeah, and by the way, I think you could also check the case study section on our documentation portal. And as far as I remember, we have some cases where the folks share their experience and they describe their cases, and payments is one of these features which is often is shared.
Yeah.
Great. Thank you very much for your answers and for this short interview. And at this point, I think we want to say goodbye and continue to the next talk.
Yeah,
Thank
so
you,
there's
Dima, Kate. Bye.
Yeah, bye. And of course, as always, we're going to see the two of them later again for the Q&A. We see that there's a lot of questions coming in from all of you, and we are really trying to get through of them. And probably the big Q&A is going to be best, because some of them relate more to Android, some of them maybe relate to a Google project. Who knows?
Yeah, we'll see. Oh, and the next, there is a familiar face on our schedule, Sebastian Aigner. Seb, it's your talk, and it will be a talk about Kotlin.js in 1.4 and beyond, right? And just as with all other talks, your questions can go directly in the chat, and we will be back to the studio together with Seb and Zalim, who is a team lead of Kotlin.js team. And yeah, also make sure to pay close attention so that you will succeed in the quiz, which appear right after talks. And for now, let's enjoy this talk.
Hi everyone, and thanks for tuning in. I'm Sebastian, developer advocate at JetBrains, and I'm excited to talk to you about Kotlin.js in 1.4 and beyond. As the name suggests, we're going to look at the new features and improvements we have added to the JavaScript target for Kotlin. We will also have an outlook of upcoming features, some of which you can already try at home, and some of which we're hard at work to bring to you as soon as possible. So, let's get into it. Let's start out by having a look at what we deliver with the 1.4 release of Kotlin.js, because there are a number of quality of life features included which are ready for you to enjoy and which we'll see today. We've really focused our efforts around providing a more unified and cohesive development experience, smoothing out some rough edges. We've also improved the number of settings and integrations you can control directly from your Gradle configuration. So specifically, we are going to look at how the Gradle plugins for Kotlin.js have been unified, new features that were added to the DSL, and how we evolve platform APIs. Let's start with the first topic, the Gradle plugins. Now, as with all technologies, it's important to have a clear entry point. In the case of Kotlin.js, those are the Kotlin Multiplatform and Kotlin.js Gradle plugins. They provide a central place to manage the most important facets of a Kotlin project targeting JavaScript. This includes things like the dependencies you want to use, the JS-specific integrations you want to enable, and more. Because these plugins cover all functionality that was previously available in the alternative Gradle plugins, we can officially deprecate those with Kotlin 1.4 and provide you with a clear way to start your project. Now, the JS and multi-platform Gradle plugins actually also provide opinionated integrations for popular tooling from the JavaScript ecosystem. As such, they include a fully managed local yarn installation, which takes care of downloading and installing NPM packages required for your projects. And if your application is targeting the browser, the plugins will also automatically use Webpack as a bundler. This integration means that your code and your resources can be turned into production assets without you having to write any specific configuration to get started. Now, both the multi-platform and the JS Gradle plugin actually expose the same underlying functionality. If you're only targeting Node.js or the browser, the JS plugin provides a simple approach to structure and build your project. But we also see a lot of developers using Kotlin.js alongside other platforms. For example, they share code between their JVM server applications and their browser frontend. Or they share implementations of their business logic between Kotlin multi-platform mobile targets and web applications. In that case, it makes perfect sense to choose the Kotlin Multiplatform plugin. To make switching between the two plugins as painless as possible, and to ensure that our materials, examples, and our documentation around Kotlin.js are applicable for both plugins, we've aligned the target naming convention between the JS and multi-platform plugins. This means that a configuration block like this one, setting up the browser target, looks the same whether you use the multi-platform or JS plugin. Next, let's talk a bit about our new support for loading style sheets without having to dive into the depth of Webpack, the bundler that Kotlin.js uses for targeting the browser. Now, Webpack is a very modular bundler that uses so-called loaders to turn files of different types into production assets. On the one hand, this provides a lot of flexibility, but on the other hand, it can also mean that more configuration of the bundler itself can be required. Since we want to reduce the amount of time you have to spend on configuring the bundler, we look at which functionality is commonly used and try to provide simple toggles directly from within the Gradle plugins. One common example for this is style sheets. Whether you are writing your own CSS or are depending on some React component from NPM, which comes with style sheets, you're going to need the appropriate loader for Webpack to handle the styles correctly. So, Kotlin 1.4 adds CSS support to the Gradle plugins. Once enabled in your build file via the appropriate flags, your project will auto-configure Webpack to use style and CSS loaders in its configuration without any further manual changes required. If you have more advanced use cases, you could also take a look at the documentation for Kotlin.js, where we cover the available, more fine-grained inclusion and exclusion rules for this configuration. Now, for now, as you can see, CSS support has to be enabled for the 3 tasks, Webpack task, run task, and test task, individually. We realize that a majority of Kotlin.js developers will probably enable or disable all 3 of these options simultaneously. So we're looking into providing a single point of configuration for CSS support to make these snippets just a little bit more concise as well. Let's move on to what's new in managing NPM dependencies from the Gradle plugins. Now, as mentioned previously, the plugins for Kotlin.js allow you to manage your dependencies from NPM, just like any other dependencies from Gradle, by using the NPM function. Internally, this generates the appropriate entry for the dependency in the auto-generated package JSON file of your project. To help reduce strange surprises, with Kotlin 1.4 we are actually also requiring you to specify a version number or a range for the NPM packages you want to use. To have more fine-grained control over the context in which your dependencies are actually required, we also introduce 3 additional functions: dev NPM, optional NPM, and peer NPM, which allow you to express the corresponding concepts directly from your Gradle build file. Of course, adding NPM dependencies is only half the process. We also want to be able to use these dependencies from Kotlin. We can, of course, as usual, write the required external declarations by hand. We could use official or community-contributed wrappers, and then use the JavaScript libraries through those. But we are also working on functionality to automate this process. With our experimental Ducat tool, these Kotlin external declarations can be generated based on type information included with the NPM packages. With Kotlin 1.4, we actually provide 2 different ways of invoking Ducat for dependencies in your project. The first is to run the generation at build time. To enable Ducat to generate external declarations for an individual dependency, you can just pass the generate externals parameter to the NPM function. You can also set a default behavior, which is only overwritten by these individual settings, using the generate externals property in your Gradle properties file. Now, we believe that Ducat is an important strategic part of Kotlin.js, and we continue actively investing in it. But since it is currently still experimental, and its generated output can be volatile, you might need to apply further changes or fixes to the declaration as it generates. Now, to make this easier, we are introducing the generate externals Gradle task in Kotlin 1.4. You can invoke it manually to trigger Ducat's generation of declarations to a separate folder. You can then tweak that code to your liking and copy it to your project source directory. Now, of course, this requires some manual input, but this approach allows you to use Ducat as guidance towards correct external declarations for your project. Now, let's move on and talk a little bit about the browser APIs. So the libraries that allow you to make use of the functionality provided by modern browsers, from the Fetch API to drawing on canvases to interacting with DOM elements. Historically, both the Kotlin browser and the Kotlin DOM packages were part of the Kotlin standard library, and as such, they had the same release cycles as the rest of the language. To allow us to deliver these improvements to DOM and browser-related APIs independently of Kotlin's language release cycles, we are starting a gradual shift for these packages towards separate artifacts with Kotlin 1.4. The first step for this is moving the packages to Kotlin X. Kotlin browser becomes Kotlin X browser, Kotlin DOM becomes Kotlin X DOM. For now, you don't need to add any additional artifacts to your application in order to continue using these APIs. Your IDE will help you to automatically adjust your import statements to the new packages, and everything will continue working as normal. As we move further with this process of decoupling, we will introduce a separate dependency for these browsers and DOM declarations, and here we can then improve the quality and the correctness independently of the language schedule. While we are on the topic of platform APIs, I also want to mention Kotlin X Node.js. Now, while it was possible to execute Kotlin.js code in a Node.js runtime for a while, for example to facilitate serverless applications or interact with server-side JavaScript, there were no official declarations available for the API which is exposed by the Node.js platform. Kotlin X Node.js provides external declarations for using exactly those APIs from Kotlin code targeting JavaScript. That means you'll be able to type safely access features that the Node.js platform has to offer, which might not be available in browsers or in JavaScript by default. Things like doing DNS lookups, to pick out a completely arbitrary example. Because Kotlin X Node.js is still experimental, there can be some inconsistent or missing declarations. Still, we invite you to experiment with the library and leave any feedback you might have in its GitHub issue tracker. Now, up until now, we only talked about topics that are all available as is once you have your project upgraded to Kotlin 1.4. But since the subject matter is Kotlin.js in 1.4 and beyond, I also want to talk about the next evolutionary step for Kotlin.js. And in fact, it is actually one that you can try right now. What I'm talking about is the new Alpha IR compiler for Kotlin.js. Sounds fancy, right? Well, the new compiler is going to be the main focus of innovation for Kotlin.js. As the naming suggests, it currently has alpha stability level. You can find more information about what promises and commitments we make about something with alpha stability level on the corresponding Kotlin evolution page. But the team who is responsible for the Kotlin.js IR compiler is working hard to make it the new default, and with it improve topics around speed, around bundle size, and also around interoperability with the JavaScript and TypeScript ecosystems. Let's take a closer look at how the new compiler attempts to excel in some of these areas, starting with the bundle size. Now, when talking with folks using Kotlin.js, we've often heard the demand for smaller bundle size, especially in larger projects or when the application spans multiple Gradle modules. The model used by the new IR compiler allows us to strengthen the dead code elimination capacity, making it possible to generate production executables that are much smaller than their counterpart created with the current compiler. The team is also actively working on providing a basic form of per module code splitting, which you will be able to configure as usual from your Gradle build file. By leveraging code splitting, larger projects can reduce the size of the first chunk that needs to be loaded, which promises improvements around metrics like the first meaningful paint. The team has also planned to gradually introduce more ES6 features in the compilation output of Kotlin.js with the IR compiler. One planned example for this would be ES6 modules, as opposed to the current support for UMD, AMD, and CommonJS. Not only would this allow you to export your Kotlin code as nice and modern ES6 modules, but this also unlocks more optimizations in regards to bundle size. The keyword here is tree shaking, something that allows Webpack, the bundler we use for Kotlin.js, to remove unused symbols and modules from your production code, improving load times and overall bundle size. The team is also looking at adding other ES6 features like classes at a later point. Now, of course, one essential step for making the new compiler the default is feature parity. The version of the alpha IR compiler, which you can try right now, already includes many of the features available in the current default compiler. But some features are still missing. One such feature is source map support, for example. Source maps are what make it possible for you to open your browser's DevTools and see and debug Kotlin code here, rather than just seeing minified JavaScript. We understand that, especially for finding bugs, this functionality is very convenient, so we are of course committed to providing the same feature in the IR compiler. I want to touch on one more topic which I mentioned in the beginning of this chapter, and that is the interoperability between Kotlin and the JavaScript and TypeScript ecosystems. We think it's really important that Kotlin.js plays nice with other web technologies and that you can conveniently use it alongside them. There are developers writing full Kotlin applications that run in the browser today, for example with React and the corresponding official Kotlin wrappers library. And while we are of course excited to see these full Kotlin web applications, this might not be possible for everyone. If you're working in a project that already has an established JavaScript codebase, for example, or are working in a team that has a large collective knowledge of web technologies, rewriting it in Kotlin doesn't sound like an appealing or productive approach. You might also need or want to work with frameworks that require specific tooling or have other specific constraints. For situations like these, we've identified a strong interoperability and a convenient way to consume Kotlin code from JavaScript to be highly important. And this is once again a topic our developers are committed to tackling with the new Kotlin.js IR compiler. The mechanism that lays the groundwork for this interop is the experimental JS export annotation, which is introduced for the new Kotlin compiler. The principle behind using it is simple. If you want to export a top-level declaration, like a class or function to the JavaScript world, you would simply add this annotation to it. It's also available in Kotlin common code, so if you have a multi-platform project and you want to export something common, that is also perfectly permissible. If you want to export all declarations in a file, you might also want to use the add file annotation. That is also perfectly valid. The new Kotlin.js compiler will then make sure that the definition you marked will be accessible from JavaScript and from TypeScript. And on the topic of TypeScript, I want to show off another feature that's currently in preview, which I'm very excited about in the new compiler. And that is the automatic generation of TypeScript definitions from Kotlin code. Now, when a declaration is marked to be exported to JavaScript, a DTS file is automatically generated alongside the compiled code, which includes TypeScript definitions corresponding to the exported Kotlin declarations. We hope that the JS export annotation, together with this feature, will really incentivize folks to employ Kotlin.js in polyglot teams, similar to that of other Kotlin multi-platform applications, where the web professionals in your team can still use the technologies they want to use, like TypeScript, but you can still avoid duplicating work for business logic-heavy implementations, creating API wrappers, and more. While the implementation for this feature is not finalized yet, all exported Kotlin declarations already receive TypeScript definitions when building with the new compiler. From the perspective of a front-end developer, using such a Kotlin.js library won't look much different from using any other TypeScript library. In this example, we have a TypeScript project set up in WebStorm, which references the compiled library from the previous slides. As you can see, the symbols can be just imported, objects can be created, functions can be called, just in the same way as you would anything else from TypeScript. The tooling support that these definitions enable in your IDE makes it really easy to discover the APIs and the way that Kotlin exposes them. And because the new compiler still just generates regular JavaScript modules, no additional magic is required on the consumer's end besides locally resolving the dependency. And that's something that's comfortably supported by all major bundlers like Parcel.js, Webpack, and others. We're looking forward to see you experiment with these new features in the new compiler, and of course we ask you to give us feedback. The keyword of experimentation provides a great segue to my next point: how to actually try out the new compiler for Kotlin.js. Because it can actually be enabled with a simple flag which is available with Kotlin 1.4. Simply set the compiler type to IR, either in your JavaScript target configuration or in your Gradle properties file. At that point, you're all set and can compile your project with the new and shiny IR compiler, given that the dependencies of your project are also already supporting the new backend. If you're using Kotlin JS for building a library, we are of course excited to see you try the new compiler as well and publish compatible artifacts. To make this comfortable for you, we've added a few things to smooth the transition. Firstly, to make it easy to switch between the two compilers, we've actually made the JS export annotation, which we got to know earlier, available in the legacy compiler as well. Here it will only turn off name mangling for the annotated declaration, but this should still make it easier for you to switch back and forth between the two compilers. We have also introduced a third choice for the compiler settings alongside IR and legacy, which represents the current default compiler. This setting is called both. As its name might suggest, selecting the both mode for the Kotlin compiler will take your Kotlin code and run it through both the legacy and IR compiler, generating artifacts in the formats used by each backend. Through the magic of Gradle metadata, both of these artifacts can actually be published under the same Maven coordinate. When you depend on a library compiled in both mode, the correct artifact will automatically be chosen at build time. If you are a Kotlin JS library developer, we encourage you to start compiling your project in both mode. Nothing scary will happen to your users who are using the default compiler, and you will make it possible for early adopters of the new compiler to use your library. Well, that was a lot of information surrounding the new Kotlin JS compiler. If you want to explore the topic at your own pace and familiarize yourself with it in more depth, take a look at the corresponding documentation on kotlinlang.org and give it a try. As always, we are highly interested in any feedback, bug reports, or issues that you encounter and share with us. Now, before we round out this Kotlin JS journey with a short summary, we want to share a brief update on one more subject which is interesting in the concept of Kotlin in the browser, and that is Kotlin for WebAssembly. As you may know, the development efforts around Kotlin for WebAssembly have been going on for a while, and they've been making some exciting progress recently. 2 team members working on the Kotlin JS team have joined the WebAssembly community working group and represent the interests of Kotlin there. Our developers are also in close contact with teams implementing the virtual machines which execute WebAssembly code. One key feature of these VMs that Kotlin wants to make use of is a managed garbage collected runtime. Now, the proposal for such a runtime has not yet been finalized, but we have already started working with prototype implementations of such an environment. We have high hopes for Kotlin on WebAssembly, and we are working super hard to get a first very experimental prototype of the technology into your hands to try and play around with. Well, that about concludes our journey through the present and future of Kotlin JS. Thanks for sticking with me. Let us quickly summarize the topics we tackled in the last half hour or so. We saw that Kotlin 1.4 brings a clear starting point with the JS and multi-platform plugins, both of which use the same configuration DSL. A DSL that now supports CSS styling out of the box, provides multiple options for how to define NPM dependencies, and integrates the Ducat generator tool. We also had a brief glance into the future of the browser and Node.js APIs and dove a bit deeper into the new Alpha IR compiler for Kotlin JS, with topics like improved bundle size and TypeScript-JavaScript interoperability. I hope you were able to learn something new and are as excited as I am about the topics that are still upcoming. If you want to learn more about how to try out the features we described, you actually have multiple options. The Kotlin website comes with a What's New section for Kotlin 1.4, which allows you to jump to Kotlin JS related topics easily. Don't forget to also check out the Kotlin 1.4 release blog post for detailed information on the release, and feel free to join the dialogue in the JavaScript channel on Slack. We are excited to hear about your feedback there, as well as on the official Kotlin issue tracker on uTrack. Thank you for tuning in, and have a nice Kotlin! Hey, it's me again. Look, the wonders of movie magic. 1 second I'm on the stage, it pre-recorded like a couple of days ago, and now I'm here. Anyway, this interview would probably make a lot more sense if it's not just the 2 moderators, because I'm the speaker here, but also someone else who can answer some questions here. So joining us in the studio is Zalim Bashorov, who's team lead for Kotlin JS. Hi, Zalim.
Hi, everybody. Thank you. Thank you, Sebastian, for a great talk.
Thanks. So I want to start off directly with a question from the community, which has reached us via Twitter. And it's actually from Viktor Turansky. Now, the people who have actually worked with Kotlin.js before might recognize his name. He's pretty active in the community. I want to actually thank him here for a second, because if you hang out in the Kotlin Lang Slack and you ask a question, there's a good chance he's going to stop by. But he asks about ES6 support and its state, especially in regards to bundle size and what kind of the future there is for Kotlin.js.
Oh, okay. So speaking about ES6, it is not about near future. Likely it's not about 1.5, but we of course working on ES6 features, but I want to say firstly what supporting ES6 features probably mostly it is some solution, and in most cases users want to probably to have to reduce bundle size, and in this term output size for us is the most important things, and we already have great result in this area with new Kotlin.js compiler, as Sebastian told about it already. And we can reduce output size up to 2 times. And we decided to what we need to focus to deliver this and some other cool features what we already have. And after that, we can try to look at some new cool features like ES6 features and so on.
Okay, that makes sense.
Yeah, and I think the next question we have for Sebastian. Seb, this is a question from Mark, and he's wondering where to start when you want to learn more about Kotlin.js.
Well, funny you should ask that. It's almost like I'm spending most of my time thinking about this kind of stuff, right? So we have a bunch of different hands-on tutorials on play.kotlinlang.org, which teach, for example, Kotlin and React. We have recently overhauled the documentation for Kotlin.js as well. So if you have more technical questions or if you're running into specific issues, you can always consult the documentation. If you're interested in MPP, so in multi-platform projects, I can very much recommend also checking out John O'Reilly's People in Space project, which you can find on GitHub if you just Google it. So it's People in Space. Because it really nicely kind of integrates all of this. John, if you're watching, hi, and thanks for contributing to the community. And of course, speaking of community, there's a bunch of other frameworks you can try, which all come with some kind of documentation or tutorials themselves. There is KWeb, there is Fritz2, and a bunch of others. If you want to kind of get started and get your hands dirty by building some small games, there's Corhe. If you want to try data visualization, there's Data2Viz, and there's many more. And yeah, if you have questions, you're always welcome in the Kotlin Lang Slack channel, of course, as well, under the JavaScript channel, where a lot of people from the team are hanging out, where I'm hanging out from time to time, and just try to help you folks get started.
Right. So many sources. Yeah, thank you. That's an insightful answer. Well, so going further with our questions, and the next one, I guess, is for Zalim. What are your plans uniting JVM and JS Kotlin, especially for concurrency coroutines? In my opinion, there are too many pointers to Java stuff and functions not working in JS. Writing library code and unite the Node.js and JVM world seems quite difficult if these gaps keep existing. Why don't you skip JS and go for WebAssembly for the libraries directly? Neither Node.js nor modern browsers should have an issue.
That is one hell of a question.
A big question. Actually, there is 2 parts. Firstly, about some unifying. In general, we are trying to unify behavior between how platforms we have, not only between JVM and JS. And
So we have a non-technical problem right here, but that's of course fine.
Second pilot, Zalim's second pilot is here now.
Yeah, sorry. So the reason why we have such difference, usually it is about something it is just hard to implement or even impossible. In the case when it is difficult to implement, it could be, the reason could be what we can implement it without performance penalty. Sometimes it just I don't know, impossible. So in these cases we just take some trade-offs between performance and unifying something, and current primitives are a good example for such thing, because JavaScript has only one thread. Of course, the browsers and Node.js have something like workers, but actually they works differently when we have on JVM, for example. Also, there is some difficulties because browser and Node.js implements it differently. Speaking about WebAssembly, I think today WebAssembly is suitable for main two things. It is using some code from C, C++, and for things like number crunching. And it doesn't work yet well for developing web applications, mainly because in terms of performance and binary size is not good enough nowadays for big web applications. So right now we don't recommend using Kotlin and WebAssembly, but we stay in touch, and we actually as Seb said, we participating on WebAssembly community groups and works closely with WebAssembly VM vendors, and we of course, if you want to track updates about WebAssembly, please join our WebAssembly channel in Kotlin Slack.
All right. Cool. Well, I think this is a good point to stop. There seems to be a bunch of other questions coming up still for Kotlin.js. We're going to try to get to those later on, but let's try to kind of stick to the schedule. We're going to say goodbye to Zalim for now. And
see you later.
Thank you so much, and we'll see you later for the big Q&A. So we are moving on to the next talk, but not before answering one more question, which was not directed at our speaker. That was actually directed at me, which was about, Sebastian, can you give some tips on how to give a good technical talk? Something that beginners commonly struggle with and what they can do about it. This is a great question, and I'm afraid that this is not the platform to kind of talk about this. But if you follow me on Twitter on @sebi_io, you might at some point come across some content which is exactly targeted on this, because I've had planned something like this for a while now. And if there's some demand, I'm glad to share some kind of insider tips here. Now, let's actually move on, though, because we have another great talk coming up, and it is a great one. You've already seen Dima Savvinov earlier today together with Kate, but he also has a talk for today. He's still the team lead in Kotlin Multiplatform Mobile, and his talk is called Diving into Kotlin Multiplatform. As usual, don't forget to put your questions in the chat for discussion afterwards, and make sure to pay really close attention, because there's quizzes and there's prizes for you. For now, let's enjoy the talk.
Hello and welcome everyone. My name is Dmitry. I'm working on Kotlin multi-platform, and quite naturally today my talk is about multi-platform. But it won't be your usual multi-platform talk about features and how you write projects with multi-platform. It will be a technical talk about nitty-gritty details and technical interesting curiosities behind the scenes which is happening in Kotlin multi-platform. So I must make a disclaimer that there are a lot of internals ahead. So please don't rely on this talk too much. I have tried my best to make sure that everything I say is correct right now, but it might become outdated in the future. So please refer to actual documentation. This is the only source of truth. And yes, I know that this kind of disclaimer doesn't work. So I will put a special mark, which will mark and explicitly the most internal parts of this talk, like internal parts. Be extra careful when you rely on them. So with that disclaimer in mind, let's start. And on 1.4, with regard to multi-platform, the whole this release is probably the story of one single feature. In 1.3, you were able to have two levels of hierarchy in your multi-platform projects. You have your common code, which has code across all your targets in your projects. And then you have a platform-specific code, which is able to provide some platform-specific API or have some platform-specific code for a particular platform. In 1.4, we are able to have multiple levels of hierarchy. For example, we might have a native source set which has code across all native targets, but not across JVM and JS targets. And it makes a perfect sense, because, for example, native targets share a lot of common, like memory management, concurrency model, working with some fundamental native libraries, like POSIX, for example. And if you have logic which relies on this, it's usually convenient to share it across all targets. And before, it wasn't possible. Now it is possible. And in this talk, we're going to see all components and all bits which are boiled down to this one big and nice feature. And also, we are going to see what's going on behind the scenes a little bit, and even learn how to play with those internal parts. So let's get started. And we're going to start with publishing. Suppose you have your multi-platform code, and maybe you want to share it with someone, with your colleagues, with friends, with families, with community. Then you publish it into some remote repo, like a bin tray or Maven probably, or something else. And in 1.3, we do not publish intermediate source sets. We only publish common source set and platform-specific ones. In 1.4, all source sets are published, including intermediate ones. And this is an important change. And to understand why we need it, let's first look at the example. It might be obvious for some of you why we do need intermediate source sets to be published, but let's just make sure that everyone on the same page. So suppose you have your multi-platform project and you have a library on which you want to depend on. Just for the sake of simplicity, let's assume they have the same structure. Then it's quite obvious that your JVM code must depend on JVM part of the library. Obviously not on JS or Linux part of a library, so it doesn't make any sense, but also not only on common part. Common part is okay, because it's common, but it's not enough. Maybe library has something up in a sleeve for JVM clients, like maybe some API connected with reflection, which is a unique feature of JVM platform. The same goes for JS, Linux, and macOS. And maybe it's not obvious, but the same goes for common code. Well, indeed, when you're writing common code, you want to use some declarations from a library, some API from a library, but only such an API which has been explicitly marked as common by library authors, because otherwise you won't be able to compile this code for all platforms. So now it should be almost obvious why we need intermediate source sets to be published. This is the same story. You have your native shared source set, and the library has one. And when you're writing code in your native shared source set, you want to depend exactly on this source set, not on common. Again, common is okay, but it's not enough. we want to have more specific API, more granular API for our case. So now that we understand why we have to publish intermediate source sets, let's take a Kotlin publishing model. And we will start with a very fundamental idea behind it. Kotlin tries to reuse as much of platform ecosystem as possible. It means that when we compile Kotlin for JVM platform, we use the same format of jars and class files. Not only it allows us not to reinvent the wheel, but also it allows us to reuse all existing platform tooling like linters, checkers, minifiers, obfuscators, and so on and so forth. They work for Kotlin JVM just as good as for JVM in most cases. So mostly the same goes for JS backend. We have a jar file. Yes, jar file isn't exactly a JS format, but inside those jar files, you will find your usual .js files, and you can use them with usual JS tooling. And native is a little bit different. For native, we have invented a new format called klibs, and we will understand why in a few minutes. So let's just keep it for now. But let's look at common. So I have said that in 1.3, we publish common code somehow. So which format we use for publishing common code? Obviously, it cannot be class files, for example, because class files is a JVM-specific format, and this is a common code, which will be compiled to JavaScript, for example. So for that, we use our own format. We still use jar files, but inside those jar files, you will find .kotlin metadata files. Those are unique format of Kotlin, and it's not present on other platforms. So it was quite a bit of theory. So let's get to experiments, to interesting part. And so here I will show you how you set up a sandbox for playing with published multi-platform library. Just take any multi-platform project, then add a Maven publish plugin, and make sure that group, version, and root project name are set. Then task publish to Maven local will appear. It's task brought by Maven publish plugin. And actually, Kotlin Gradle plugin plays well with Maven publish, so we will set up all necessary defaults for you. So you just have to call this task. And after this, your project will be published into your local Maven repo, which is usually located in your home directory in .m2 folder. So let's look at the example. I have created a very simple multi-platform project with group ID hello MPP, and you can see how I stand in my local Maven repo in group hello MPP. And then my project called mympp-lib, and you see multiple folders. Each of these folders is a Maven artifact. Let's walk over them step by step. So first of all, we have a folder and artifact without any suffix. It's an auxiliary artifact, and we will get to it a little bit later. Instead, let's look at -js artifact. So just as we have learned before, we publish JS part as jar file. Indeed, we see a jar file. And if you unpack it with any jar utility, you will find exactly .js files with your code inside. Almost the same goes for JVM. It's published as jar files, and if you unpack it, you will see class files inside. Again, just as we have learned before, native part is published as klib, and the most interesting part is this artifact called -metadata with the suffix -metadata. It's actually a common artifact, and it contains your published common code. And indeed, it is published as .jar file, and if you unpack this jar file, you will find .kotlin metadata files. Okay, so with class files, you can use any Java decompiler or Java P tool to view the bytecode in a human-readable format. With JS files, you can just open them with text editor. But what about .kotlin metadata files? And well, the most convenient and user-friendly way to pick into Kotlin metadata is to just open them in IDE. And for that, you just create any project and depend on a library which contains Kotlin metadata. For example, on freshly published library, Just make sure that you don't forget Maven local in your build Gradle in repositories section. And then let's open an IDE and look at the right-hand side of IDE. There is a tool window called project structure. You usually see all files of your project here. And at the bottom of this tool window, you will find a drop-down menu called external libraries. Here you will find all libraries on which your project depends on. And this includes multi-platform libraries and all their parts. So on the slide, we can see all platform-specific parts like Dash.js, Dash.jvm, Dash.macOS, and also a common part, Dash.metadata. And IDE works well with those artifacts, so you can just browse them as your usual files and folders, and even open files inside like Kotlin metadata files. And if you open any Kotlin metadata file, you will find something like this. Just for the sake of example, I have decided to take a more interesting case and the library and took a Kotlin standard library. Yes, Kotlin standard library is just a multi-platform library. It has its own command part, and this command part is published as jar files with Kotlin metadata. So all API, which is common across all Kotlin standard libraries, like for example Kotlin.string, you will be able to find it in .metadata files. And we will see something like this. So we can guess that Kotlin metadata has almost all information about your declarations. We see all modifiers like final, open, operator. We see all methods like length, compare to, equals, get, hash code. We see all super types like comparable and char sequence. The only thing which is missing are bodies. And yes, this is a major limitation of Kotlin metadata. It is not able to carry bodies of your function. And this is one of the reasons why we have invented a new format. And we will talk about it like on the next slide. But before that, let's get back to our question. So we wanted to know, how can we publish an intermediate source sets? And now that we know that common code is published as jar file with Kotlin metadata, so we might guess a very straightforward solution. So why not use the same scheme for intermediate source sets? How native is different from common? And actually, yes, we could use the same scheme. But the question is whether we see Kotlin metadata format as a format of future in Kotlin ecosystem. Do we want to see it everywhere in 3 years, in 5 years, in 20 years, and so on and so forth? And the answer is unfortunately no. As we have seen before, Kotlin metadata has major limitations, like it's not able to carry bodies, and it also has some other flaws. So instead, we see an ideal future of Kotlin ecosystem, something like this. Everything is published as klibs, or at least you are able to publish it as klib. So, and actually in 1.4, Kotlin.js compiler already has an experimental mode in which it will publish your Kotlin.js code as klib. Native compiler already does that, and the same mode is in development for JVM backend. And for common code, we also have an experimental explicit opt-in, which will enable compiling your code, your common code, to klibs. So klib is a Kotlin-designed, Kotlin-centric format of publishing your code and sharing your code. It's common denominator across all backends, and it is able to carry multi-platform stuff around. Okay, that was a lot of theory about publication of multi-platform libraries in 1.3 and 1.4. So let's take a look how it works in 1.4 and jump to experiments. To set up the playground for experiments in 1.4, you would have probably the same configuration as in 1.3, with the small important difference that you have to put this flag in your Gradle.properties file. This is because this mode isn't enabled by default in 1.4, at least 1.4.0 and 1.4.10. And we want to make sure that we got all things right and we won't break and won't have to change something in future, at least something significant. Then the rest is mostly the same. You have your publish to Maven local task, and then you can navigate to your M2 repo just as before and find a published multi-platform library. Let's focus on dash metadata artifact, which is, as we remember, a common artifact. You would expect to see a klib extension here, but in fact, it's still a jar file. This is because we have to work with some limitations and restrictions imposed by requirements of compatibility and also requirements of ecosystem we're working with, which is a Maven, JVM, Gradle, and so on and so forth. So it's still jar file, but inside this jar file, you will find unpacked klibs. So it's almost the same as I have said before in ideal future. And here's a very important and very internal part I want to tell you about. So if you will play with this setup, you will probably notice some weird inconsistencies. And I will tell you about why it happens and why the reality is a little bit different from an ideal picture I have shown before. So let's start with basics. So as we remember, all platform-specific source sets, like JVM, JS, Linux, and macOS on this example, are published as platform-specific artifacts, -js, -jvm, -linux, and so on and so forth. That's something we know already. Common artifact is published as -metadata artifact. That's something we know as well. But then what about intermediate source sets? And well, you might have expected to see them in common artifact, in -metadata artifact. But actually, there is a very important exception. Let's look at native source set. In fact, this source set is much more native and much more platform specific than common. You expect to see Kotlin standard library here, Kotlin native features like memory management, some diagnostic checks, and so on and so forth. And in that regard, it makes much more sense to publish this source set as part of platform-specific artifact, like -Linux and -macOS in our example. So in fact, when we publish intermediate source sets, if a intermediate source set is compiled for 2 or more backends, like JVM and JS in our example, then it goes into common artifact, in -metadata artifact. And if it is compiled for the one single backend, like native source set here, then it goes into corresponding platform artifacts. It's something very, very internal. And actually, in 1.4.20, we still change and evolve the scheme further. So in 1.4.20, there will be no -metadata artifact, and the contents of -metadata artifact will go into a root artifact without any suffix. So you can see that this mapping is something very, very internal, something we change frequently. And if you somehow, by some reason, depend on this scheme, please go and tell us. We are very curious about your case. Okay, that was probably everything I wanted to tell you about the layout of artifacts in Maven repository. So let's look into artifacts in particular. Let's look into klibs. And as usual, the most convenient and user-friendly way to pick into klibs is to get a start project, declare dependency on a library which contains klibs, and then you open this project in IntelliJ IDEA, and then you will be able to browse klibs just as usual libraries. For the sake of example, I have taken a Kotlin X coroutines core, which is a Kotlin multi-platform library, and we are looking at a native part of Kotlin coroutines core for macOS x64. So first of all, klibs is just your usual zip files with a strictly defined layout inside them. So you can take your usual zip utility, decompress klib, compress it back, make sure that you change an extension, and then it most probably will be the same klib as long as you don't change its inner structure and layout. Inside klib, you will find a folder called default. This is a mechanism reserved for improving compatibility of Kotlin binary artifacts in future. Currently, there is only one folder called default, but maybe later you will be able to find multiple folders here. But all those folders will have the same layout, so we can take a look at default folder. Inside it, you'll find a folder called IR. IR stands for Intermediate Representation. Actually, this is a substitute for Kotlin metadata, but it's more flexible and it's designed with multi-platform in mind. And we can already see one major difference of IR from Kotlin metadata, which is bodies.knb file. Those are actually bodies of our functions, methods, and properties, and everything else. Something which Kotlin metadata wasn't able to carry around. So we can see how IR overcomes one of major disadvantages of Kotlin metadata. If we talk about IR as a format, then it's mostly just like a tree representing the structure of your code. If you are familiar with some theory about compilers and programming languages, then you probably know about abstract syntax tree, and IR is almost an abstract syntax tree, but with much more information and rich format, but roughly you can see it as just an abstract syntax tree. The next folder is link data, and that's a good old Kotlin metadata. And yes, I know I have said that Kotlin metadata isn't suited for Kotlin of the future. So that's why we have invented klibs and IR, which are the formats of the future. But now I say that we put Kotlin metadata in klibs, which is weird. But in fact, Kotlin metadata is perfectly applicable in some cases. And it's very convenient to use Kotlin metadata, for example, in tooling, in IntelliJ IDEA. So currently it stays here. Maybe in future we will migrate our tooling to IR, and then we will be able to drop Kotlin metadata, probably. But maybe we won't do that, because Kotlin metadata is very convenient and it actually improves performance of our tooling, so maybe it will stay here forever. We don't know yet. It's something we have to decide. Then we have a folder called resources, and this is a folder reserved for multi-platform resources. Then we have a folder targets, which is an obsolete folder. Let's not pay attention to this folder. It probably will be gone in the future. And finally, we have a manifest file, which is a text-based, human-readable, key-value manifest for internal purposes of klibs and compiler, just like a manifest in jar files. You can open this manifest with any text editor and read the internals of klibs. Well, not klibs themselves, but flags and how compiler works with them. So that was a lot of information about publishing multi-platform libraries. We have learned about Kotlin metadata. We have learned why it's not good for Kotlin of the future. We have learned about klibs and IR, which are the formats of the future. So I hope you have found something interesting and useful for you in this section. Now let's continue with the next feature of 1.4, which is a simplified dependency management. In 1.3, you had to declare dependencies on each part of multi-platform library manually, from a common part of your project to a common part of your library, from the JVM part of your project to the JVM part of your library, and so on and so forth. In 1.4, it's enough to declare only one dependency on the whole library, and Kotlin Gradle plugin and Gradle will do the rest for you. And again, before seeing what's going on behind the scenes, let's take a look and understand why we really need this feature. Because it might look like a small removal of boilerplate, but in fact, it's much more important. So let's start with a simple case. We remember that we have to dependencies from common part to a common part of a library. So all those dashed lines are lines in your build Gradle files, which you have to write manually and figure out manually. And for this case, it might not seem as a very complex task, like just put a suffix dash GVM and you're fine, and or suffix dash Linux and so on and so forth. But what about more complex cases? Imagine library you want to depend on has a really complicated layout. And I was kind enough to write this diagram for you. But I doubt that each library will have this diagram. So imagine that you have to figure out for yourself. You have to dig into documentation of a library. You have to figure out all those source sets, their names, relations between them, and then you have to figure out on which particular source sets you want to depend on. And then you like, why I am doing programming, I don't want to do that anymore, and it's awful. We don't want you to give up on programming, so we want to make things better. So before just saying that we have a lot of magic together with Gradle and everything works fine, let's take a look at how it happens and try to figure out some intuition about what exactly this automatic magic does. And for that, let's take a look at several examples. First of all, is it okay to source set called JVM to depend on a source set or this library called all except JVM? Well, the answer is obviously no. It literally says all except JVM. JVM is not okay. Well, what about Windows? And now it's much more less obvious question, because it might be appealing to say that this is okay because source set says all except JVM and Windows is not JVM, so it should be fine. But actually, if you look at this library, you will see that it doesn't even compile for Windows. It doesn't provide API for Windows. So actually, this dependency is not okay. And probably just an unfortunate naming. A library also meant all by all targets I'm compiled for, and we have thought that all is all possible targets. And it's pretty unfortunate. Okay, let's continue. What about source set called Linux and GS? And yet again, it's not quite obvious from the first glance, but if you look closely at the library on the right-hand side, you will see that source set called all except JVM actually compiles for Linux and JS, and also for iOS and macOS. And this means that it provides an API for Linux and JS. Therefore, this dependency is okay. And you can see that this process is very, very non-trivial. So we need some mental framework to work with it, so that make it a little bit more easier and not rely on a vague naming, which might be unfortunate. So in 1.4, in Kotlin, we have a notion of platform, like Kotlin multi-platform, we have multiple platforms, and so on and so forth. And actually, platform is not just a single value of enum, like JS, JVM, or native, or common. It's actually a set of those enums. So for our source sets, Linux and JS source set has a platform which is set of Linux and JS. And it says that this source set compiles for Linux and JS. JVM source set is just a set of JVM, Windows is just a set of Windows, and this source set, all except JVM, with non-obvious name, its platform is a set of macOS, iOS, Linux, and JS. And now it can be used to clearly define rules which dependencies are okay and which are not, because sets form a subset of relation. And this relation might induce relation something like is subplatform of. So because Linux and JS is a subset of macOS, iOS, Linux, and JS, it means that this dependency is okay. And if it's not a subset, like JVM isn't a subset of macOS, iOS, Linux, and JS, then the dependency is not okay. And that's actually a basic fundamental rules which we use in automatic magic going on in our Kotlin Gradle plugin and in Gradle itself when we infer all those dependencies automatically for you. Okay, that was a lot of theory, like some sets, relations, and maths. So let's get back to our experiments. The setup is just the same. Just take any multi-platform library and publish it to your local Maven repo, then browse it. And you remember we have skipped this artifact without any suffix, just my MPP-lib. We have said that this is an auxiliary artifact. And this artifact actually is needed to, it's actually needed for multiple things, but one of the things is to simplify dependency management. Inside this artifact, you will find a file with extension.module. This is a file with so-called Gradle module metadata. You might have heard these words if you're working with Android, for example. And if we look into this file, we'll find a large JSON with a lot of words in it. So I have only selected an interesting part, which is called variants. So libraries have variants. What is a variant of a library? Well, it's a part of a library, or maybe a view of a library, some facet of a library. And so multi-platform library actually have multiple variants. It published as a JS variant for JS clients, as JVM variant for JVM clients, and so on and so forth. But it's still the one and the same library. And all those variants are enumerated here. And they are marked with their platforms. So you can see here that we have a section attributes, and it says that this library has a JVM, it has a JS part. And this JS part is available at this path. And we can see that this path is exactly a JS published part with jar file, with .js files, or klibs in a new mode. So basically, when you declare dependency, Gradle goes and downloads this file, goes over all variants, and then it like, oh, you have a JS part in your project. And I see that this library has JS part as well. And I can find this JS part here. So I will download and add to your project for you. That's basically what happens with this automatic dependency management. And it's quite cool. OK, let's get to the next feature of 1.4, which is using native dependencies. In 1.3, in your native shared source sets, you were not able to use some native libraries, like a POSIX, for example. In 1.4, it is now possible. And it's actually might not be obvious. What was the reason behind it? Why we were not able to use POSIX in your native shared code? Because POSIX is present almost on every native target. And actually, the reason is that we want to be sound in multi-platform, and native dependencies are tricky to be sound with. So suppose you have your project with your native shared source set, which shares code across Linux and macOS. On Linux, you actually depend not on just POSIX. You depend on POSIX for Linux, which is a separate instance of POSIX. And in macOS, you depend on POSIX for macOS, which is somehow a little bit different from POSIX on Linux. So in your shared code, you cannot depend on POSIX for Linux or POSIX for macOS, because then you might accidentally use API, which is unique for that platform. And then your common code won't compile for the other platform. So instead, you would like to depend on POSIX for macOS and Linux, like a common POSIX between macOS and Linux. And obviously, such a POSIX doesn't exist in the real world. No one has written this library. So we could write this POSIX manually, but actually, it's very, very tricky and most probably engineering infeasible, because we will have to write an exponential number of POSIXes for you. Because between each two platforms, there is some non-trivial intersection. So either we write an exponential number of POSIXes for all possible combinations, or we provide one common POSIX between all of them. But the issue is that this common POSIX is this small. It's almost useless. So we have no other option than consider each case and each set of targets on a case-by-case basis. And well, if it's not feasible to write it manually, then let's write a program which does it for us. And that's what happens in 1.4. We have a POSIX for macOS and have POSIX for Linux. And Kotlin toolchain just transforms them and automatically infers a common API between them. And it provides you with this POSIX for macOS and Linux, which are needed exactly in your case. And well, that's kind of interesting stuff. So let's quickly jump to experiments with it. And to experiment with this technology, which we call commonizer, you have to set this flag and you have to set it exactly to false. And yes, I know it's kind of what, but yes, sorry. I hope we will make it more straightforward in next releases. For now, just bear with us and put this weird string in your settings Gradle together with other weird strings in your settings.gradle. Then you have to create a project with the native shared source set. And on the slide, you can see a very, very small snippet of how you do it. In your project, you're probably gonna do it a little bit more elaborate, but still it gives you a rough idea. And finally, you just either import the project in IntelliJ IDE or run task Gradle.commonizer. Then, if you have set up everything right, you will see something like this. The task run commonizer is launched, and we say that we are preparing an inferring and common API for you. It takes a few minutes because you might guess that it's not a trivial process. And after that, you can just use the IDE. And in our good old familiar external libraries view, you will now see something like this. You will see multiple POSIXes. And you can see something weird here. You might guess that POSIX for iOS ARM64 is a platform-specific POSIX. The same goes for iOS x64. But what about iOS ARM64 and iOS x64 is a common POSIX? But what about those POSIXes with small stars? And actually, that's because Kotlin toolchain doesn't produce only a common POSIX. It produces a common POSIX and accompanying platform-specific parts for that. So this POSIX with star near ARM64 is an ARM64 specific part of a common POSIX. And it might be a little bit hard to wrap your head around this at this point. So let me show you an example. And it should be pretty clear why we have those multiple libraries here. So suppose we have two platforms, platform 1 and platform 2, just for the sake of simplicity. We have a class foo. It has some common method called common and platform-specific methods, platform 1 and platform 2. And we have a property common wow, which is a common property, just the same property on both platforms. So what happens after inferring this common API? Well, obviously, we see a class foo in the common part. It contains only one method, which is a really common method between two platforms. It's an expect class. We use expect actual feature here. And on platform 1, we give an actual implementation, both for common method, and also we add an additional methods specific for that platform. So it's pretty natural. But what about common property? Well, we could declare an expect property and provide an actual implementation, actual implementations on both platforms. But it doesn't make sense because this property is exactly the same on both platforms. So why not just lift it from platforms to the common code? And that's what we do. And now you can see that all those 5 code snippets are different. The code which has been platform-specific for platform 1 is different from platform-specific code for platform 1 after commonization. It has received some additional modifiers like actual, and some declarations has been lifted to common, and also some other stuff changes. So that's why we have this notion of platform-specific POSIX before commonization and platform-specific POSIX after commonization. Oh, okay, that was a lot of information. And it was a quite tightly packed talk, so let's have a quick recap what we have learned today. First of all, in 1.4, we publish intermediate source sets. In 1.3, we haven't done that. And now we know that we needed to make it possible to depend on granular API of a library. In 1.4, we slowly switch from jar with Kotlin metadata to klib with IR. And for common code, it is enabled under explicit opt-in. We have learned about klibs, which is basically a zip file with a strictly defined layout. And Kotlin metadata is a set of serialized Kotlin declarations And so the same goes for IR. So IR is just like a bytecode for Kotlin. And internally, it is represented as a tree of your code. Finally, so not finally, but the next thing we have learned is that Gradle metadata helps us to declare dependencies once. And we even learned how it works behind the scenes. We have learned that we have notion of Kotlin platforms, which are sets, and they has this kind of ISA platform of. They have a notion of compatibility, which helps us to determine which dependencies are okay and which are not. And finally, Kotlin toolchain in 1.4 under explicit opt-in is able to automatically infer a common API between your native libraries so that you are able to use them in your native shared source sets. Wow, that's a lot of information. And with a lot of knowledge comes a lot of power. So I ask you to use this power wisely. Do not depend on it too much. And if you do, please tell us. That's probably the biggest help you can offer us at this point, because multi-platform is still a evolving technology, and we do not know all your use cases. So maybe we have missed something, and we have accidentally forced you to use those internals for your use case, because you just have no other option. And if you do, please come to us and tell us about your use case, and we will think about it. And maybe we will find a better solution which won't force you into using internals which are unstable and might change at any minute. And that's it. Thank you for listening to this talk. Hope you enjoyed it. And have a nice Kotlin.
All right, and we are back. Thank you, Dima, for this wonderful talk. He's also joining us now once again here on stream. Hey again, Dima.
Hey.
So hey, let me first of all say thank you so much for this talk. I personally really enjoyed this. I have to say it comes from the bottom of my heart. Love the pacing, and I always love getting new secret powers and figuring out how things work.
Yeah, and
everyone wants secret powers. Yeah.
The best part about your talk is that you're explaining all the difficult stuff under the hood of the technology in really simple words with comprehensive examples, and this is pretty cool. Yeah, thank you very much.
Yeah, it's something I'm very passionate about. I like deep technical talks. I like listening to deep technical talks, and I'm always amazed by folks who are able to explain complex things in simple words and make it useful for auditory or entertaining for auditory. So I've tried my best to follow them. And actually, I have a question to auditory, to everyone who is listening to this stream, or maybe you're listening to a recording later. Please write in chat or reach us somewhere else, maybe fill a feedback form for this event, reach us on Slack, in email, everywhere you can, and tell us, do you like deep technical talks? Would you like to see more deep technical talks about Kotlin? And if yes, then about which particular areas? Because it was kind of hard for me when I was preparing this talk to find, details which are interested not only for me as for developer of Kotlin toolchain, but for everyone else. So you would help us greatly with this.
Yeah, yes, this is cool.
It certainly is, and I think I can only encourage once again everyone in the chat to give us feedback, and everyone who's listening, because I want to see more of these talks, and of course, if more people benefit from it, it's even better. Now we're gonna move on to the big Q&A in just a minute, but we have a couple of questions that we want to direct to Dima directly. And of course, I have the wonderful advantage of being a moderator here, which means I get to ask my own question before all the other ones. So sorry for everyone who has to wait.
Oh, you're a cheater.
Yeah, a little bit, but it's one of the perks that comes with the job. So you mentioned that the JVM target for Kotlin is also going to move to klibs at some point. And I was just wondering if you could share some information about how this affects the interoperability with Java, right?
Yeah, I mean, it's a very nice question. Thank you. And it shouldn't affect very much. So we still keep in deep interoperability with Java in Kotlin. And the main question is whether you have any pure Java consumers. So if you have consumers which do not know anything about Kotlin like at all, they're pure Java clients, then you might want to publish the good old bytecode with class files. If you care about only Kotlin clients, then you can just go with K-libs. And if you want to support both of worlds, then you just can publish 2 artifacts and we'll just work with them depending on which clients consume it.
Okay, that's a good answer. Thanks.
Thanks.
Okay.
We have a next question from Joseph. Is there a plan for having also pure Kotlin common modules without specifying any target, which is now mandatory, and possibly publishing them and using in a platform agnostic way?
Yes, that's another great question, which is quite often asked. You have seen in my talk that we are like in the middle of migration to the beautiful world of the future with K-libs and IR. And you have probably seen that previously we were not able to serialize bodies. So it was kind of hard to carry multi-platform code around without bodies. Now, as this limitation is slowly going away, as IR backends become more and more stable and robust, we really hope that in future we'll be able to consider this case for real, because we're also excited about this case.
Thank you. And yeah, let's go to the next question.
Okay. We have one more question, which comes from TC, who asks, when will Kotlin provide interop with C++ instead of using JNI?
Oh, that's a great question. And actually, it's a little bit, you might be tempted to mess up things here, because we have Kotlin native, which is about native world, and it even has an interop with Objective-C. And you have Kotlin JVM, and now you have JNI, which kind of bridges two worlds together. So it's very easy to be confused here. But if we're speaking about interop with C++ as a substitution for JNI, then probably we are talking about a tool which generates wrappers around C++ interfaces and corresponding JNI bindings for Kotlin JVM. And currently, we do not have such a tool in our plans, but it definitely sounds very interesting and sounds like a great topic for our internships, which are yearly annual internships, and also maybe a good contribution as soon as IR infrastructure will get more stable. So maybe.
Okay, so if you want to keep an eye out and maybe work on that, you can always check jetbrains.com/careers, where we also put up all our internship points.
Well, we were chatting with Dima beforehand, and he said that he's glad to join us for Big Q&A question and cover questions about multi-platform and maybe more technical questions. So I suggest we can move now on and skip to our upcoming segment with all the speakers, and inviting them to our studio for a big Q&A of the day. We will actually have two more guests joining us today, which were not speaking today, but can answer your questions. Svetoslav Sherbina, team lead in Kotlin Native, and Kevin Galligan from Touch Lab, which is our partner. So let's.
All right, let's bring him in.
Yeah.
Hi, everyone.
Hi.
Hi.
It's either good to have you back, or it's nice to see you for the first time on stream. Either way, it's great to have all of you here. So we have a ton of questions that we want to get through, I think. Alina, do you want to take us in with the first one?
Yes, sure. Let's do that. And I guess the first question will be addressed to Kate. Okay, the question from Mariam regarding KMM applications. Is it better to use Firebase for both versions of the applications or to use Cater clients instead? Please explain your answer and kindly provide us with more resources for both ways so we get to decide for ourselves. This is a complex one.
I like the formulation of the question because it makes it sound like an exam. So show your work.
Yes. So I feel a little bit nervous now because so much pressure. But it depends, as always, because I think we can't compare them because Cater client is just a universal HTTP client, and you can use it for all your APIs and connecting to all your services. And Firebase SDK is an SDK. And if you need some Firebase services, you definitely can use it in your application. And you can even use both of them in your KMM module. So just go do it.
Okay, sounds good. I'm going to throw over a question to Slava. Why does Kotlin native produce Objective-C code instead of Swift code?
Well, okay, first to clarify, Kotlin native does not produce Objective-C code. It's not a transpiler like JTopC or whatever. Kotlin native produces native binaries and additionally can add some bridges to support using Kotlin declarations from other languages. The Obc header is a part of such a bridge, but there is no actual executable Objective-C code generated. Next, producing Objective-C bridges allows using Kotlin with both Objective-C and Swift. I guess this is more than just Swift, am I right? So this is the first reason. And the time we implemented this interoperability, this probably was more important than now. But I believe that having support for Objective-C is still a good thing. Next, at the time we implemented this interoperability, Swift didn't have stable ABI and actually was evolving quite fast. So producing Swift bridges would be considerably complicated. Now things have changed, but we didn't support Swift yet.
Okay.
And finally, using Objective-C bridges turns out to be more flexible in relation to both language integration and runtime memory managers cooperation. That's
all right. Okay. Thanks for that.
Yeah, that was really insightful. And I guess the next question goes to Florina. How does coroutines handle configuration changes? Async task doesn't show app crashes secure, but how does coroutines do the same?
Well, coroutines don't handle configuration changes. Coroutines by default, has nothing to do with Android. It's a standalone library. I think if you want to handle configuration changes, what we usually recommend when it comes to working with coroutines on the UI layer, so somewhere around the view model and in the activity and fragment, is to use coroutines together with live data. So in your view model, you can transform your, let's say, Kotlin flow to live data. And then in your view model and in your activity or fragment, you would just use live data because that's an object type that supports configuration changes. And also, I feel like this is like a Russian roulette. Okay, who's going to be the next person is going to be us. It's like we never know.
Yeah, that was like that. So, but maybe anyone else has more comments on that.
That was
Great.
a good Russian roulette. Yeah.
Very good.
Unexpectable, yeah.
I was going to say it's a problem that we have to kind of solve on the native side for iOS, which is like I'm currently having a discussion with the team of like on the Android side we're using live data. What are we going to do for flow on the iOS side? And there's no live data for iOS, so we have to sort of figure that out. I don't have an answer. I'm just commenting.
Well, let's maybe kind of tack onto that one. Kevin Shetan asks, how steep would you say is the learning curve for Kotlin multi-platform mobile?
That's an interesting question, and there's a lot of things that might go into that answer. I think, we did a lot of work on this thing called CampKit, which is just like a getting started, app example with basic stuff like database and coroutines and views and stuff like that. Because like we wanted that like 10-minute getting started experience to be pretty good. From there, if you're just doing data network calls, as long as you follow best practices of like not modifying your data classes in stream, things like that, it's not too bad. Obviously, if you get into the weeds with concurrency, that's kind of what I talked about for the last couple of years, over and over. It's new, so don't expect it to just work the same. And of course, it's changing. So I would say it is not too steep if it's pretty straightforward, and it gets steeper the deeper you go, or the higher you go, or whatever. I don't know. Bad analogy.
Okay.
Can I just add something here?
Absolutely.
Yeah, I just want to highlight that I think things have changed dramatically during the last months. Not long time ago, we had a hands-on for KMM or KMP or whatever you want, and I think it contained about 5 or 6 or 7 steps, and the result was an iOS and Android app with shared KMM module with Hello World string. And now you can do all this with Android Studio plugin just in a few clicks. And current hands-on describe you how to create the complete application with data storage, networking, and else. So I think this difference is great for newcomers. But of course, Kevin is right. And when you come to some more tricky part, for example, multi-threading, things become not so easy to understand. Yeah.
I would say, yeah, totally. Like I was working from the world of like a few months ago. The new docs, the new website, definitely laser focus getting people started, which is super, super important. So, and certainly the plugin too. It's a great addition.
Yeah, and just to continue here and don't make anyone to feel like they're on Russian roulette. We have a question about some code labs, and is there something that you can get started with for KMM? Any suggestions for code labs or other materials where you can start for KMM?
I think this hands-on that I mentioned in my talk is a good one, but KMP from TouchLab is also a great way to start experimenting with your own apps. So just visit our portal. We have links for all kind of samples and talks, and just feel free to go through it and do some KMM magic.
Great.
Okay. I have a question for Zalim. So I'm gonna continue the Russian roulette. No one will ever know who comes next. But this is all part of equally distributing. Yeah. Well, this is all part of equally distributing questions. But we're gonna start with an easy one. So in common tests, I want to use method names in backticks that have spaces, but I cannot use it because it's not supported in Kotlin JS. Will this ever be supported, or is this particularly difficult?
In short, we are considering to removing some limitation here. Can't say now when exactly we will do it. It was forbidden to avoid to save users from some problems when they use Kotlin JS and minifiers or for their JavaScript APIs because many minifiers when see call access something using brackets, they stop minifying it. In some cases, they just don't understand what accessing using brackets and accessing without brackets is the same. So, yeah, that's all.
Okay.
Cool. And the next question will be for Dima. And it's a question from Andre. Hello, the question is, what prevents you from creating 2 or more JVM models in an MPP project? How actively are you currently working on this? And whether in 1.5 you can expect to see the Ktor server and Android client side by side in one project?
Yeah, I actually saw this question, and like the main part of it is that it's not just two JVM modules. You can, of course, can have them in your multi-platform application, but about sharing logic and code between JDK, desktop Java, and Android, like JVM for Android. And that's the case we have in mind. And it was very hard to get there like a year ago. Now, as we have this kind of sharing and have this support for hierarchies in our structure and all toolchain up in our sleeve, it's much more closer to us. So now we are think about it in much more realistic terms. We don't have midterm plans. You have seen our roadmaps. There is no JVM and Android code sharing there, but it's something for us to consider in the future.
All right. Cool. So the next question, maybe we can direct it at Kate. We'll see. I'm just going to throw it out there. It's, again, a Kotlin multi-platform question. What's the advantage of using expect actual over the existing pattern of using an interface and injecting the implementation?
Oh, that's an interesting one. Frankly speaking, when I started digging into KMM, I also had such question. So I will continue to play with Russian roulette, and I will proxy this question to Dima.
Oh yes. Oh, thank you. Okay.
I don't know was it legal or not, but
it was neat.
I think Russian roulette doesn't work in this way, no? Anyway,
it's the equivalent of pointing the gun at someone else. It's
Okay. Anyway, actually, if you are not using an expect actual for some I wouldn't say advanced cases, but expect actuals allow you much more than interface inheritance allows you. And if you are not using the full power of expect and actual mechanism, you just want to, for example, hide bodies. You don't care, like you have exactly the same function with exactly the same signature. It just has the same, the different implementation on different targets. Then you probably can get away with interface and dependency injection. But an expect and actual mechanism is much more powerful. It allows you to change and enhance inheritance, for example. So you can declare an expect class and an actual class. You can add more super types for it. Something which is not possible with dependency injection. You can do various stuff with signatures, like you can change types in signature, which is not always allowed in interface inheritance. You can change modifiers, like for example, actual function can be more visible than expect one, like expect one can be private, and actual can be public, for example, and that's fine for multi-platform. So I would say that if you don't see why you would use expect and actual instead of interfaces, then probably you should consider interfaces. And whenever you feel that they are too restrictive, consider expect and actual.
I just want to jump in there real quick. I would say like we actually, in practice when building stuff, especially if you want like this testability, like if you can use an interface for coarse grain stuff, absolutely. Like we tend to push to not using expect actuals. But yeah, as you get into other contexts, there's a lot of stuff you can do with it. But I wouldn't default to starting with expect actual for everything. But you kind of tend to do that when you start because it's a new thing and you're like, oh, this is what you're supposed to do. But not every case.
Okay.
May I add my 2 cents?
Absolutely.
Expect actual actually resolved statically, and it means what you have not any runtime penalty. So that's cool.
That is neat. Okay. Anyone else want to get in front of this? Maybe it'll mean that you'll get to be a bit quiet afterwards. Who knows? No, the roulette doesn't discriminate.
Yeah,
Alina.
and the next question will be for Florina. It's from Florian. Is there any reason advantage in returning live data instead of flow from room retrofit?
Multiple parts of this question. I think, first of all, for retrofit, you can't return flow because these are one-shot network requests. So you would probably use a suspend function for that. But I would actually recommend against using live data on the data layer and rather use something like Flow or ArcJava if you want a stream of data from Room. And that's because, unfortunately, the live data comes with a series of disadvantages when compared to Flow. So first of all, Flow has a lot of operators. So this means that it's quite easy to transform the data that you get from your database, while live data isn't as flexible. And then second, live data will always return the result on the main thread. And that's probably not something that you want to do if you want to handle that data in the repository. So I would say on the data layer, prefer using Flow.
Okay.
Thank you.
All right. Now I have a question, and I'm going to answer it myself. Here we go.
Wow.
As I'm telling you, the roulette does not discriminate. The question
is so wild.
The question is, will Kotlin decrease speed in competitive programming as it needs the JVM? And this is actually kind of an outlier in all the questions, but I still feel the need to address this because unfortunately we couldn't have Xenia, who's doing a lot in education and also with competitive programming, on during the first day of the show. The answer to this is there are teams that are using Kotlin for competitive programming very effectively. And if you want to learn more on this topic, I would suggest going to JetBrains TV on YouTube and looking up the video Kotlin for competitive programming, which is by Mikhail Dvorkin. He has a multi-part series which explains some of the best practices for using Kotlin in competitive programming if it's interesting, and it will probably make it very clear to you that the JVM is not going to be the bottleneck if you choose your algorithms wisely in this context.
Wow, thank you, Seb, for bringing it up. Maybe more comments on competitive programming?
Not a comment, but I have just learned that we have those videos, so I'm definitely going to check them out. I'm super excited about them.
They are very
so useful
interesting.
Q&A.
Yeah.
Great. And the next question goes to Slava. It's from Lev. When can we expect the new Kotlin native memory model to arrive? It's really important for us who have high hopes for native Kotlin. And yeah, they say conference is great. Thank you.
Well, thank you for the question. You can expect new memory model when it will be ready. Because we know it's not just new memory model, it's the entirely new memory manager written from scratch. So don't expect it tomorrow. We also had to invest some time to our infrastructure to make the development easier. So overall, it will take some time to make it.
Thanks. That was it.
Okay. I'm gonna throw another question out to Zalim here, and it comes once again from Viktor Turansky, and he asks about JS import and export are currently non-synchronous, meaning that the namespaces don't necessarily match up with kind of what you would expect. Are there plans to sync the JS exports with imports so that they are symmetrical?
Thank you, Victor. Actually, it is an interesting observation. I didn't think about it from this angle before. And I think we are going to look at exports in near future, and probably we will consider something in this area. Our goal is to improve user experience. If we go deeper to the technical details here, the problem here is when we export to Tableau without package prefix, it creates a bunch of problems for our tooling, starting from IDE to provide good experience to user, to find name clashes. It could be problematic for incremental compilation and so on. But I hope we will find solutions for all these things and make user life better.
Wonderful.
That's it.
high hopes for the future here.
Yeah. And I have the next question for Kevin. A question from Fedi. Is there any way to make a unit test and instrumentation test for the KMM, like what we do in Android?
Well, unit tests, sure. You can write common unit tests and have them run. The difficulty, and we're honestly still trying to solve this ourselves, is what happens when you get higher up in the layer. Like if you're running an Android and you want to use like an instrumentation test with the Android, context running. Obviously on the Android side, that's pretty straightforward. iOS side, it's a different thing. So I don't have a good answer, to be perfectly honest. Some things you can totally get in there as long as they're available. Like you can test SQLite, you can test a bunch of other stuff. Anything that is not included out of the box in platform specifics that are the interrupt platform specifics is more difficult. And we've experimented with that, like calling from an XC test and passing in Swift lambdas, but it's a tougher road, and we're in the process of trying to figure it out ourselves. I don't know if the other team members have any other ideas.
Yeah, that's probably, you have described it pretty nicely. I would just like to reiterate that you can write unit tests. Indeed, if you go into more, sure, you can write unit tests, and there is like this idea of local tests which run on your host machine in order to speed up your development cycle. But yeah, you're totally right that if you go into more like deep advanced cases where there are more platform specific stuff kicks in your tests, and it gets more complicated. And yeah, we're also try to think what should be the best approach we should recommend to everyone for their tests.
Yeah, you can like compile the native to have an entry point that you can call from Xcode. Let's say I'm talking just iOS. Obviously, if you're talking Linux or whatever, I have no idea. But it is not something that's like I wouldn't say it's unsupported as much as there's no documentation around it, and it's a little tricky, but it's possible. Beyond that, yeah, it's tough to figure out.
Okay. I'm going to throw another question to Dima here. And this one is actually kind of close to my heart as well, even though I didn't ask it. Why is Kotlin string format only available on the JVM?
Gosh, I don't know. I have no idea. It's a surprise for me as well. Let's have a format on each platform. But I guess that we maybe we are not fine. Like I might imagine that Kotlin string.format borrows the form from respective Java methods, and maybe our design team isn't quite happy with how it works and how it looks, and overall design. So it's kind of a tough situation when you don't want to make a pull decision, like a temporary decision, because it will be hard to deprecate and take it back. But you don't have resources to design string.format right now when we have a new memory model, KMM going on, and all this stuff. So yeah, it's a tough situation.
Okay.
Great.
I think Kevin wanted to add
I was going to say, I think it might also be localization related. And if you have a tough question you don't want to answer, just say localization too. I think.
Clever.
Yeah, so what suggests Russian roulette is to ask Kate. Yeah, is there a way to debug Swift code generated by KMM?
Slava, brief please about Swift generating from KMM, but I understand the question and the use case is to debug KMM application. And yes, I love this question, especially because now I can advertise our plugin, our new KMM plugin, and I think one of the main reasons to install it is that we have the unique functionality to debug your KMM application on iOS. So yes, you can solve your problem.
So comment from Slava? No?
Another lection about generating Objective-C code from Kotlin native. Yeah.
Okay, so I can choose the next question for Slava by myself. Yeah, so the question from Werner. Is there now coming a GC runtime to Kotlin native?
Well, absolutely not, because the GC runtime was there in the first public release. So what I'm trying to say is that since the first day, Kotlin native applications do have managed runtime, which has something like garbage collector, which scans the heap from time to time, which can actually cause GC pauses. If this is your concern. And to the best of my knowledge, without scanning the heap, you can't actually collect cyclic garbage. You may also know it as retain cycles. And without collecting cyclic garbage, you won't actually get Kotlin on native targets, because inability to collect cyclic garbage actually affects language and the library's design quite a lot. So without GC, you will get not Kotlin, but another language like, I don't know, Swift with Kotlin syntax or whatever. So in fact, we are just going to rework the GC under the hood from scratch, generally to simplify concurrency. And also this work could eventually improve the situation, for example, by reducing latency if we end up with a concurrent garbage collector. That's all.
Thank you. So what else? I guess one more for Florina. I just lost it. Oh, okay, it's here. It's one from Kaya171. Is live data heading towards deprecation in favor of flow?
I feel like this is the question of the year. We've been getting this question quite a lot. At least right now, not really, because in the end, live data still has the lifecycle advantages. So I would say we're still debating on this. Also, there are some libraries like data binding that right now don't support flow. But side note, we're working on that. So I would say we are going towards that direction, but it's not possible for now to do that. I would say check out your application and look what you're using. Live data and maybe some instances can be replaced with flow or state flow. But when you're talking about interaction with the UI, probably not.
Okay. Well, as I said, the roulette doesn't discriminate. So this next question goes out to Alina.
Oh, wow.
And the question is, will there be a talk about Ktor and its roadmap tomorrow, coming from Alexandra?
Yeah, there was a false start. I've already answered it on chat, but yeah, there will be a talk on Ktor tomorrow by Hari Hariri. And so everyone is welcome and join us tomorrow. And it will be live. It's a spoiler. Yeah, it's gonna be live talk. So get ready to answer your questions, and Hari will ask your questions, and Hari will answer them. That's how the things work.
Yeah.
Like, oh my God, all previous talks weren't live. Oh my God.
Oh no, is that the first time?
Oh no. Okay. Well, I'm gonna throw out another one here, coming from Andre. Who says, will there be some kind of decompiler tooling for IR in the future? I'm going to throw this over to Dima.
Yes, probably. It depends on what you mean by decompiler, because you have a basic decompiler. I have shown it even in my talk, when you can browse a compile.kotlin metadata or klibs, and IntelliJ IDEA will decompile, but only headers of Kotlin metadata or IR. And the big question is whether we are going to decompile the bodies and what will be the quality of this decompilation. But I guess so eventually, because it makes perfect sense.
Okay.
Zalim or Slava, would you like to add something?
Well, I'd like to add that if this is someone's concern, we can actually, it is technically possible to, obfuscate the internals of KLite, so it won't be possible to decompile the bytes if you don't like it. But we don't have this at the moment, but this is still possible.
Yes, thank you. That's a good point.
Yeah, I totally agree. What eventually we will have such tooling. Actually, we have some dumping for IR, but it is not. If you not read a lot of such text, it would be hard to understand what happened there.
Yeah, I guess
in terms of
I guess it's not a direct decompilation because you don't get the source code back. Like it's just a deserialization of internal structures.
Yeah, in terms of obfuscation, I think it will not be problematic. Obfuscator can generate some another IR, what far from original.
Okay. I'm going to throw out another quick question to Kate, because I think that answer is going to be very short. Does one need a Mac to run the iOS simulator?
Yes.
Great, there we go.
Okay.
That's the end of that story.
Okay, so
Wait, you mean KMM is locked for Mac? Wow.
Oh, yeah. No, but you can compile your KMM SDK with Kotlin native, not on Mac. You can compile it on Windows, on Linux, on Mac. But to compile whole application, iOS application, you need a Mac, and this limitation goes from the Apple side. So yes.
All right, nothing we can do here, folks.
So one more on KMM. Not sure who would like to answer it, but let's just see. It's a question from Ethan. How can I send feature requests to the Android JetBrains team for the KMM plugin?
Wow. I was so
it's even worse than Russian roulette, right?
Okay, I was so confused by Android JetBrains team.
KMM plugin after.
Yes, but yeah, so first of all, if you have a feature request, we have a tracker for Kotlin. You can find it kotlin.in. And yeah, just submit an issue or feature request, and you can write anything you want here. It's like one of the design channels to communicate with requests from our community. So just don't be shy. Like a lot of people are very shy about submitting an issue now. Like say, oh, I don't have a minimum reproduction and I haven't investigated like all other 100 cases. No, like you can just go and say, my project doesn't work. Here's a commit. Please understand what's going on, and we will do it for you. Also, there is a public Slack, but probably if you have a complete feature request, you can just go to our packet.
So I think maybe it's a good time to clarify that KMM plugin is the result of JetBrains team and Kotlin team, so you can definitely use utrack here.
Yeah.
Just to clarify.
Yeah, that's the core of the question. I mean that someone who asked wasn't sure whether it should go to Android team or JetBrains team. So yeah, this clarification is very appreciated.
Oh yeah. Oh,
cool.
I see it.
Seb, would you like to pick up the next one?
Yeah, and I think this might actually be our last one here.
Okay.
It goes out to Kevin once more, and the question is, what about the performance comparison between Kotlin Multiplatform Mobile and native applications? Is this something that people should be concerned about or think about?
That's the last question. Thanks for the easy one.
No, we'll do another one afterwards, just so that the pressure is gone, apparently.
So, should you be concerned about performance? Like, of course, as a general rule, but performance is kind of a tricky thing to measure, right? So you'll see people are like, hey, I ran this in the JVM and I ran in Kotlin native, and they're nowhere near each other or whatever. But benchmarks are funny things. For example, I wrote SQLite driver that's underneath SQLite, and with some optimizations we should be putting in there soon, that'll run faster on native than Android because there's no JNI, presumably. I don't know exactly why, but not blindingly faster, slightly, right? You have to you're building an app, usually in a native mobile situation anyway, you're like calling a network, getting data from disk, orders of magnitude slower than anything you have to worry about computationally, right? So I don't know, should you worry about it? Sure. Should you stress over benchmarks of one thing compared to another, which are kind of arbitrary? I don't. They're ballparkish, especially when you compare to like Swift, which is a more natural comparison currently than the JVM, right? I think the team is nodding heads to this. Yes, it's a more fair comparison. I would say the other thing that was asked in questions was about size. And then I have a long-standing blog post about binary size, which is a whole different thing. But the short version is, with some best practices, they're, equivalent-ish compared to if you're doing Swift code, that kind of thing. It's a much longer talk. But I would say short version, don't worry about that stuff unless you're writing like something crazy, in which case, I don't know. C++ may be something you should look at, but I don't know what to say about that other than that.
All right. Thanks a lot for that. Sorry for throwing you under the bus like this with the second to last question.
Okay, maybe the last one. Everyone who has related experience is really welcome to share. And this is a question from Melvin. How do you convince the iOS developers in the company to learn or write Kotlin in order to maintain MPP code?
I feel like I've heard this one before.
Yeah.
How do you convince iOS developers? Is that the question?
That is the question.
Yeah.
Oh, well, I would say, and this is the thing that we said a bunch and check out. I think Kate wrote the thing that's on the KMM site. Start with empathy. If you're an Android developer and the web team shows up and says, hey, you don't need to do that anymore, we got this other thing. Don't come in that strong, perhaps. Look for allies, especially, in any production environment. Any build system is going to be really hard to just slam something into, especially if you're not accustomed to that kind of build system. So certainly that is true. And this is a lot of what I've been dealing with day to day is how do you put Kotlin into a production iOS system without disrupting what's going on there on a day-to-day basis. So it's not trivial. And you're going to need folks from the iOS team to help out. And so let's look for curious folks in any dev ecosystem. Some people are going to say, no way, I'm not looking at any of this. But that's not everybody. So,
Okay. And I can add something here. Maybe I think you can use the strategy when you do the step by step. And I think this is a common scenario when first on the Android part of the team is contributing in the shared code because that's a very familiar ecosystem for them, and the iOS part just consuming the library. And then when you make it all right, they even don't think about it because they just use an API. And after that, step by step, like, oh, maybe you want to fix this bug here, like, and after some time, you'll find your team pair programming the new KMM module. So yeah, and you can check the article. We have a separate article about convincing your team, as Kevin mentioned.
There's other stuff too, like because it's incrementally, you can add small things. You don't have to make a big decision. Pick things that nobody wants to do. So I don't know a ton of iOS developers who love core data. So doing database modules is maybe a place to start. A lot of bigger teams are starting to do like typed analytics libraries because most developers that I've worked with, and myself included, don't really enjoy adding analytics strings all over their app, like that kind of stuff. And then, yes, trying to pull some of the iOS engineers to start contributing code. Like some team we work with, the first time you submit a pull request that's shared code, you get like a mug or something, and you're part of, stuff like that. I don't know. Read the article. It's you know, it's like anything.
Make a team building before that, and
Well, I think the key takeaway from this is very nicely put, is to use empathy. I think that's very nice. I think, and I think that's probably a good point for us to close this out as well. I think we're a bit over time anyway, but there were so many questions in the chat. I don't even think we got through all of them regardless. We'll try to answer some of them offline as well. But for now, I want to say goodbye to everyone who was on our panel and say thank you, of course, for all the insights that you've shared, for all the knowledge. And yeah, just thanks a lot. And yeah, we hope to see you again sometime. So take care, everybody.
Thank you.
Thank you.
Bye-bye.
thank you.
Bye,
Bye-bye.
everyone.
Thank you.
There we go.
Yes.
Wow.
That was cool. That was insightful.
Yeah, what a day. So what people maybe don't know is that we did not plan this Q&A to go this long, but there were really so many questions that we decided that we would just keep going for a little longer. And once again, thank you so much to all of our panelists who decided they could stay on a little longer as well.
Yeah, and thanks for everyone asking these wonderful questions and yeah, providing this opportunity for us to stay here and discuss all of this.
All right, well, that's pretty much concludes our broadcast. Of course, we would like to encourage you to tune in tomorrow, where it's all about Kotlin on server side. I think there's going to be a lot of exciting topics coming up there. As usual, please don't forget that all the talks we had today do contain a quiz quest. So those t-shirts and backpacks and bottles, they're still up for grabs and up to win for you folks. And yeah, I think that's about it, isn't it?
Yeah, that's it. Thank you very much for staying with us, and see you tomorrow.
Have a nice evening, everybody, or morning, or whenever you're from.
Wherever you're
Bye.
from, yeah.